For some reason, it's not writing as a full. All right, I'll try again. Float ABC, and then we need to ask the user to enter 3 numbers. And then C in A, B, and C. Okay, now we can start. We need to get them in increasing order. So let's check for increasing order by starting out with if A is less than B. Then A and B are in increasing order. Then check to see if B less than C. Start with the obvious case. So A less than B, B less than C, both are true. If both are true, then C out A and a blank, B and a blank, and C. That's the order, right? So now, else. Now the logic gets intensive as we proceed, so you need to follow that carefully. Now A, the case right now we are looking at is A is the smallest. I'm writing the smallest at the top. A less than B, so B is bigger and C is larger. That's the case we looked at. And now we are looking at, so in that case, A, B, C is the answer, so we wrote that. Now the else, if I write else, that means this else is paired with this if, and therefore B less than C is not true. That's the case we are looking at. So in that case, the B is not here. So that means A and C are still in that order. No, I'm sorry, A is less than B is true. So A is still smaller than B, smaller than B. So B, A less than B is true, but B is not here. So the B less than C is not true means B can be now above A or below C, right? Okay, so that's the case we need to look at. So therefore, I can compare the B against C to see if C is less than B. No, B is less than C. B, because C less than, that's the case we already looked at. B was bigger than C. So therefore, so B less than C is not true. So B, let me change that erasing here. That was incorrect. All right, let me start over by saying A less than B, B less than C. All right, A less than B, B less than C was the original case. And in that case, we wrote the answer. A, B, C is the order. Now, B less than C is not true. That's the case we are looking at. So B less than C is not true. Means B can be A less than B is still true. So the question now is A less than B is still true. So the question now is where is C? So C is not below B. So that means C can be here or above A, right? Those are the two possibilities. To determine that, we need to compare the C against A to see if it is above A or below A. So that's why I'm going to compare C to see if C is less than A. That means C is up here. And that means CAB is the order. So C is no longer here. C is, C could be here or here. And we compared against the A and determine right now that C less than A is true. In that case, C is the smallest one. 1 second. So C goes first, and CAB is the order. And if that's not the case, we already know that C is not down here. And so we just compared C and A, and if C is less than A, then C is above A up here. Okay, and in that case, C is the smallest one. If that's not the case, then C must be here. We already know that C is not below B. And so else, so if that's not true, then C must be here, which means ACB is the order. So C out, ACB. Are you with me so far? Okay. The case A less than B is what we worked out. A less than B is true. Then if B is smaller than C, then C is down here. And in that case, ABC is the order. If that's not true, that's when else is executed. That's not true. Then C is not down here. A less than B is still true. And therefore, A less than B is still true. You keep working in that case. So therefore, C must be either above A or below A. So by comparing C against A, right here, we determined CAB or ACB are the possible orders. So A less than B case has been worked out. So now we need to go into C. The case that A less than B is not true. All right, okay. Andrews, you still have a question?
Yes. Okay. So now here's the thing. I did the same thing, and the machine and the code told me that the second else, the else that has the orders A, C, and B. The machine told me that this else was not precedented by if, so the code is invalid. So that's the part I don't really understand. So every else should have an if, right?
Yeah, I forgot to write the if there.
Because no, here's the thing. The textbook also is missing the if. Yeah.
Else
no.
if. You can't write else without if. So this last else is paired with this if. I failed to write it, but that's.
Oh, okay, understood. Because yeah, I mean, I did the same thing, and I was like, what should I do? Should I put if or like, leave it as to else?
No, you cannot have two else's. That's an if I forgot to write. Yeah.
Oh, okay. Understood.
If C less than A, then this is true. Otherwise, this is if C less than A, then this is the case. Otherwise, this. If else, so this is all one block, and I don't. Yeah, you need a bracket here just to make sure. All these are in that if, right? So you have to put a bracket there. That's necessary. Now, if I write else, this else is paired with this if. So that means A less than B is no longer true. So let me move the screen over. A less than B is no longer true means B must be less than or equal to A. The equality case is something we don't need to worry about, because if they're equal, anything is equal, then you can write them in any order. So equality case, you don't have to worry about. So A less than B is no longer true means B less than C. The smaller one I'm writing above. So B less than C. B goes above C. In that case, I need to see where A belongs, right? So A can be above B, below C, all those different places are there. So I need to compare the A against B to see if A less than B. I'm sorry, that's the case we already know, not true, right? We are looking at the else for A, if A less than B. So that's not what I need to do. I wrote the wrong thing here. A less than B is no longer true. So B, I wrote B and C, that's not true. We are looking at the case that this condition is not true, which means A less than B is not true, means B must be above A. Okay, so we need to know where C is. So we can compare the C against A or B, but I'm going to compare against A. So if C is B less than A, so if C is bigger than A or A less than C is true, that means C would be here, right? So in that case, BAC is the order. So C out B A C. Otherwise, C is, if C is not here, then C can be here or here. To determine that, I have to compare C against B. That's the only way to determine where that is. So if I need another if, else if, so C is not below A, so C can be here or here. So I need to compare against B. So if C less than B, then C is here, then CBA is the order. CBA. If that's not the case, then C is not here, means C has to be here. So BCA is the order in that case. Else C out BCA. And that takes care of all the possibilities. And so, yeah, I don't need any other brackets because these are all else ifs. Else ifs don't need brackets. All right, Kevin, what's your question?
Um, for the project 4.441.
Yeah.
So like I submitted it yesterday and you graded it. And I don't know if you remember, but like I was the one that like put I didn't do the error corrections.
Yeah.
Okay, which is like, and I okay, well I resubmitted it with the right I submitted with the right corrections from the book, but there's also like one thing that I didn't really understand because so I used I printed the output that was asked on the book, right, which is 60 and 110. I don't know if you remember. And you
Yeah.
said you said that my number 60 is wrong, which is you said it let me pull it up real quick.
Yeah, the 60th number you found was wrong.
Yeah, but the thing is like you said it should be like 18205 whatever, and then
Yeah.
but you know I looked up the Fibonacci sequence number of 60. It's a different number. Like it's the number that I got on the program, and the reason why it's 18205, which is what you said
Mhm.
is the right answer, is because it's an int, which that number doesn't fit inside of an int. So like so
Yeah.
I don't understand because also like you said to use int on inside the you said to write int on the book,
Mhm.
but at the same time I don't know if you see number 4.
Yeah.
It says the program should be written to work for any size of value of n. If I used int and I plug in 50, it becomes a negative. So
Yeah.
like I'm not really sure like if you really wanted me to use the int or double there. I thought it was okay to use a double.
Double is for floating point numbers. So what you need is long int. Long int doesn't give you 8 bytes when you're using a microcomputer. So that's one of the reasons why I decided not to go into 110th. 110th number doesn't fit into int type memory cell. It doesn't fit into 4 bytes. And that's why you get wrong number for that. you get a negative number, because remember I said if it doesn't fit, it only fits the bits that can be fit in that memory, and that gives you a totally wrong number, which is it comes up a negative number. So yes, if you use int, it's going to give you wrong answer for large numbers, and that's one of the reasons why I changed the numbers to 30th and 60th, I believe, and avoided 110th. So you're saying the 60th number didn't fit in the int type either?
Well, you know, like if you put 60, like for the sequence number, it'll become like the Fibonacci number is like 115,480 something, which is what I got.
Okay, so that's wrong number coming up. Wrong number coming up in my case, I think. Maybe
Oh, yeah.
you're right. Yeah, it's
Yeah,
possible.
But
Because
isn't it like a little bit confusing? Because like number 4 says like it should be written to work for any size value. Because like I was thinking is like, well,
any
like
size within the 4 bytes. Yeah, I should have made it more clear, because we are all using microcomputer, and microcomputer doesn't even allow long int. So we are limited to 4 bytes. And so just that's why I changed the problem to have 30th number and 45th, I believe. 30th and 45th, I think. I didn't even want to go into 60th. So
yeah,
if
no,
you
it's
find,
not. Yeah.
if you just find 30th and 45th, it might work out. It might be okay.
Yeah, I resubmitted the right one if you wanted to, if you still wanted it.
So you
Like,
submitted by email?
yeah, like last night.
Okay. All right, I'll accept that, but remember to make these changes. I already said many times, the changes that have been posted on the blackboard should be done on your book.
Right.
If the book is ebook, then you should have that document printed and have it in front of you, so that every time, every problem, you need to compare against the corrections and make sure the corrections are done. Okay.
Yeah. All right.
All right. So I'll accept that second version of the project. Any other question? All right, moving on. Anything from today's assignment, which is, I'm going to bring it up. 4.1, 4.2.
Wait. To be clear, so the answer was to use int or just long int?
You can try long int, but it's not going to change anything, because
Oh, okay. Oh, okay.
in the microcomputers, the long int also gets 4 bytes.
Yeah, this was I was confused. It was giving it the same.
Same number, right?
Yeah,
So
yeah.
no use of using long int unless you use a bigger computer, a mainframe or mini. But we don't have access to that. So you just change some. That's why I changed the problem to have 30th and 45th. If you find those, it will be fine. Okay. All right. Any question from section 4.1? Oops, that's not question. That's answer. Where is my question? All right. These are the problems. Is there any problem in 4.1 I should go over? Or 4.2? All right.
Real quick, I'm sorry.
Yeah.
Question 8 with the Celsius Fahrenheit conversion. So in the beginning, like Fahrenheit and Cell are both declared under an int type. And then on the bottom,
Wait, which question?
question 8.
8 in 4.1?
Oh,
Yeah.
I think it's 4.2. 4.2.
4.2, the Fahrenheit Celsius, okay.
So I got most of it right, but I guess so. What is where would I would declare down in the 4 statements that Fahrenheit equals, and then parentheses.
Let me write it so that everybody is clear how to write it, and then we'll discuss. So I'm going over problem number 8, 4.2, number 8. And the Celsius goes from 0 to 80. For all those Celsius temperatures, you need to find Fahrenheit. So there is no reason to introduce another variable to control the loop. A couple of students did that. That was, unnecessary and make it long. And, the Celsius clearly is the one that changes from 0 to 80. So let that be the control variable for the loop. Declare the variables Celsius, and I want to declare both of them as float so that because we have fractions in the expression, so our answer is going to be float. So make them all float. So float Celsius, comma Fahrenheit, FAHR is enough, and that's all we need. And then we say for Celsius going from 0 to Celsius going up to 80. Celsius incrementing by 1, right? So loop is controlled by the Celsius because that's the one changing here. For each one, you need to calculate the Fahrenheit. So Fahrenheit equal to 9/5 times Celsius. So 9/5. So you need to put a decimal point next to one or the other or both to get correct answer here. Times Celsius plus 32. And then you need to write them in 2 columns apparently, right? Second column, yeah. So I need brackets. Now I need second statement, Cout statement. Cout Celsius in 1 column and then \T. Corresponding Fahrenheit goes there, and E and DL. E and DL. And then close the loop. So now that's all we need, but according to the problem, we should have appropriate titles. So you have to write the title before the for loop begins. So up here, Cout Celsius \T Fahrenheit. ENDL. Okay, so write the title up there, that's all you need.
So I guess my question, so even when you declare Fahrenheit as a float, you still need to put the dot after the 9?
Yes, because this calculation right here is independent of what the other variables are. Okay,
Yeah.
so that division, if you have integer to both operands, you're going to get wrong number.
Okay.
So one of them needs to be float. Okay. All right. Any other question? Okay, then we'll.
Number 10 on last night's homework. I don't understand. I just want to know what it's asking because I was having a hard time understanding what it was asking.
Well, number 10 on which?
Last 4.4.
4.4, I haven't graded.
I know, but I want to understand the instructions because I did not understand that question at all. I don't know. I think it was me, but like I couldn't comprehend what it was asking. Maybe it was me.
4.4, number 10, you said.
Yeah.
Write a C program to find and print the negative integer values of x in the range -52 to 0. That satisfies the equation. In the range, you need to determine whether any number in the range -50 to 0 would be a solution of this equation. Understand?
So I had to equal 0.
Yeah.
Oh, okay, then I did it right.
To be a
Okay.
solution of an equation, it has to make the equation true. So when you plug in the number for the x, it should be equal to 0.
Oh, okay. And basically it's asking for how many numbers that go into it.
Yeah, so you need to check all those x's, and whenever anything is a solution, you need to write it and also count it.
Oh, okay.
You need to count
Thank you,
out.
Professor. I did it right. I thought it was harder than it looked.
It. I don't know. It's very clear. You know, in the range.
I know. I think it was just me. I didn't understand it at all, like what I was asking. I think it was just confusing for me. But I still did it properly, I guess.
All right. Okay. Kevin, what's your question?
Yeah, hello.
Yeah.
Just to be sure, number 10, the output is it 0, by the way? I just wanted to.
Number of solutions actually is 0. Yes, there is.
Oh, okay. All right, because I was
Right.
like,
Yep.
and
Right.
can you go over 4.4, the fourth question? I just want to know if I did it right.
4.4. Which one?
Question 4.
All right. We'll go over all of them after I grade them.
No,
Okay. At this point, it would be, you know, I mean, I found, you know, in the past, it's beneficial when everybody knows which one they got wrong or right. You know, after that, if you have the discussion, it helps them. Okay. So it's best to spend the time afterwards. So I'm going to get out of that. We will go over that, which is not far away, tomorrow, right? Tomorrow I'll have them graded and I can go over them after that. So right now, 4.1 and 4.2. If there's no other question on that, I'm moving out of that. And your test is going to be tomorrow. And so we need to go over the, I mean, the answers are there for the practice test. So you shouldn't really have much to ask, but is there anything you can understand? We need to go
Professor,
over?
I have a quick question. You know the exercise you posted on the left side, like the class exercises.
Yes.
Is there is there a way you could put like the answers? Because sometimes like I don't know like how I can check if my answers are correct.
Yes, my experience shows that if I just put answers for everything, students just read the question and answer, then they think that they have learned it. It doesn't work that way.
You can use the question from like the previous on the homework. Like, so, you know, like, so for the odd numbers, if you actually need help, they actually help a lot if you look at the answer key for the odd numbers and then relate it back to like the even numbers.
Right.
I don't know if that's printed in the ebook. It's like, which is the one I'm using.
The ebook has answers for the odd number.
Okay, I'll look it up later then.
Professor.
Yeah.
So for like this one, I have two questions. Number one, is it accumulative? So is the second exam going to be chapter 1, 2, 3, and 4, or just 3 and 4?
Just 3 and 4.
Okay. Second question. When doing this review, since we don't have an answer key, I understand the concept of an answer key you're talking about, but like, if you could give us at least the answers of odd numbers, at least we have something to like compare the answers with. Otherwise, we don't know.
Exercise for the class exercise.
Yeah, I mean, like, so here's
Okay.
the thing. You did a big favor.
I'll do this. Not everybody is doing class exercise. So anybody's doing it. If you want to find out what is right and what is wrong, I can take them, or you can email the.
Oh, Professor, yeah, I was gonna email them, but I don't know how many like you were gonna grade because I did like 4 of them. I didn't know if you're gonna grade all, like check all of them.
Or I can create a link, this is not going to be counted as assignment, but
Okay, that's fine.
just
Works for me.
to have you
Practice.
have you submit and me correct, that'll be helpful. So for that reason, I can create some links. And
Okay, yeah, that works too.
I'm not part of the grade book. Okay.
That's fine, yeah.
Yeah, I'll do that. Okay, for the other students who are not understanding it, they're talking about the class exercise. You see on the left side of the screen, I have the Blackboard, and there is class exercise link. There, I have many exercises, additional exercises that students can use. They're posted here. For example, let me open. We're into loops now, so it should be somewhere in class 8 or 9. So these are additional problems that you can do to practice. Always doing more and more problems will make you better and better in this. That's how it works. Like math, it's just like math. So if you want to do additional problems, these problems are there. And if anybody wants to submit for me to check, not for grade, these are additional exercises for your practice, I'm willing to do that. So I can create a link, where should we begin? Should we begin at?
I feel like we're fine for like the first, for the first exam, like those 2 chapters are fine. I feel like, can we begin from like, maybe like
Great
nested if statements?
Okay.
Yeah, that's where I feel less confident. So so here's the thing. I didn't ask for this because it's really hectic for you just to go over all the class exercises that we do.
Yeah,
that's the reason why I couldn't email you anything. I don't want to bother you too much, but yes, it is really helpful if you could do that.
Okay.
Thank you, Professor.
You're welcome.
Thank you.
I'll start with the nested if, whichever that is, and post a link for that. And others who are not interested in doing it, you don't have to. I know everybody is limited with time, and I understand it. But additional exercise always helps. If you can find some time to do them, it will be helpful. So I'll create the links for the class exercises. But if you remember, they're not going to be counted, so you don't have to submit them. All right, so moving on. We are back to the supplements and review for the exam. And the answers are there, so you should be able to understand from the answers if you did anything wrong. Otherwise, if you need any explanation on any of these questions, feel free to ask now. This is the only chance. I will not take questions on this again later.
Wait, which question are you?
I'm looking at the review for exam 2.
Can you do number 17?
17, okay. To read, let me enlarge that a bit. Okay, problem 17, you can see on the screen. Write a program that reads floating point value for X from the keyboard and compute the sum of this series. Okay. All right, so we need to compute the sum of this series for the given value of X. The value of X is going to come from the user. All right. So whenever the problem says write a program, you need to begin with the main. Otherwise, you can just write the statements. So here I'm going to begin with the main. And I need variable X declared, and also float X. And then I also need a variable sum to hold the sum of all that. So sum should be set to 0 initially. And then the numbers 1, 2, the X, initially X denominator is X plus 0, and then it's X plus 1, and then X plus 2. So there is a number there that we need a variable for. So that can be integer. So I can declare int n is initially 0. That I'm looking at the denominators, and the first denominator has x plus 0. The other ones are 1, 2, 3, and so on. Okay, so so the n is going to control my loop. The n in the denominator, the first denominator is 1 over x plus 0. The second one is 1 over x plus 1, and then x plus 2, all the way to x plus 50. So that 50 clearly is the last one. So that means I should control the loop by the n, which is going from 0 to 50. So I started my, you can do a while for loop also, but I'm using while loop. I started n at 0, and I'm going to say while n is less than or equal to 50. I need to repeatedly do what? Add up. I'm sorry, before the loop, I had to get the x from the user. So before the loop, I need to get the value of x. So write cout, enter value of x, cin x, and then I can begin my loop while n is less than or equal to 50. Sum equal to sum plus, we are adding up here. So to the current value of sum, I need to add the 1 over x plus 1 over x plus n, right? 1 over x plus n takes care of it. Right now n is 0, and I'm going to change n to 1, 2, 3, and so forth, so on. So after adding 1 over x plus n to the sum, the n should increment by 1. So I can write n plus plus on the next line, or, I mean, C++ offers a nice way of doing that right here. Then I don't have to write a separate line for it. And that's pretty much it. See, when initially n was set to 0, and n less than 50 is true. So therefore 1 over x plus 0 will be added to sum. After that, n will become 1. And now we are checking n is under 50. So 1 over x plus 1 is added to sum, and then n changes to 2. And so as long as n less than 50, it'll keep adding 1 over x plus n. And the n is changing from 0, 1, 2, all the way to 50. So this is it. That will add up the series. And when the loop ends, you write cout sum, and that'll be it.
You have to put the point after the 1 when sum equals sum plus.
I don't need it because my x is float, and so everything will be float.
X is float, okay.
Yeah. You don't need, since x is float, the entire denominator will be float. So therefore, the division will be fine. Okay, so that's all we need.
Okay, thank you.
Can you do 15?
Write a program that obtains 3 integers from the user and prints the smallest integer between 2 and 20 that divides all of them evenly. Okay, so you need to get 3 numbers from the user, and then you need to find the divisor between 2 and 20, what numbers divide all 3 of them. The common divisor for all 3 of them, that's what you're finding. Okay, so yeah, it says program, so I need to begin with the main. And the numbers are going to be integers, so int A, B, C. And we are writing the smallest integer. We are writing only the smallest integer that divides all of them. So we're finding a common divisor, but smallest, which is same as what we call least common divisor. So that'll be, I'll call it test number for the devices. All right, so I need to get the numbers from the user. Obtains the integers. So you need to get the numbers, 3 numbers. Cin, A, B, C. And there are different ways to handle this. You know, you're only finding the smallest divisor. So when you find one divisor, you want to stop the whole process. You don't want to try all the other numbers. You don't need to test other numbers. So we're going to test numbers from 2 to 20 and determine which one divides all 3 of them. And if we find one number that divides all 3 of them, we can stop the process. So to stop the process, you can use one of 2 different ways. One of them is to use a flag variable that can be set to 0 or 1. You can change the flag variable when the smallest divisor has been found. That'll be one way. So I'm going to use that approach first, and then I'll show you another way. So that flag variable is going to be set here. I'm going to say found. Found equal to 1, equal to 0 means smallest divisor hasn't been found. When smallest divisor has been found, I'll set the found to 1. Okay, so that's my flag. I'm going to start with, I can use for loop or while loop to test all the numbers. I'm going to use for loop for test going from 2 to test less than or equal to 20, because that's what the problem says. Between 2 and 20, you need to test all the numbers. Increment test by 1. And I'm going to test all of these numbers to see if any of them divide all 3. You need to divide all 3. So if A modulus test equal to 0 and B modulus test equal to 0, and it has to divide all 3 of them. So, and C modulus test equal to 0. If all 3 are true, then we found it. We found the divisor. So if that's true, then C out the test, and also set the found to 1, because we found it equal to 1. And then whether this happens, whether this is true or not, whether these conditions, all these 3 conditions are true or not, the test number should go up, and that's what happened here. Test number goes up, and the next test number will be tested here. So the loop will continue to test, but if the item is found, the smallest divisor has been found. In other words, whenever the first divisor is found, first divisor of all 3 of them is found, the found will be set to 1. So we need to stop the loop when the found is set to 1. So I need to go back to the loop and make an adjustment. Otherwise, there's no use. The loop will continue even after finding the smallest divisor. So I need to make an adjustment to my for loop so that the loop will stop when the smallest divisor has been found. So I need to say test less than or equal to 20 and is found, found remains equal to 0. Only if both conditions are true, the loop will continue. And if found changes to 1, the loop will stop. So this way, after finding one number, the loop, one divisor, or smallest divisor, loop will stop. We still need to write something after the loop ends. When the loop ends, if there was no divisor found, then the found will remain at 0. It is possible that between 2 and 20, there's no number that divides all three of them, right? So we have to take care of that possibility. So when the loop ends, if found is still 0, that means no device is found. But if the found became 1, then we wrote a divisor. Only when we find a common divisor, we write that divisor and set the found to 1. So therefore, we don't have to worry about the case found equal to 1. It's already taken care of. Test number was written. Only if found is still 0, that means no device was found, and the user should be told that no device was found. It's because when a program is executing, the user expects some conclusion, and you shouldn't leave the user without anything. Okay, there must be something. So if there was a divisor that divides all three of them, then we will be writing that, and that answer shows up on the screen, so the user knows there is this common divisor. If there was no divisor, then this loop will end up writing nothing. And that's why I have to do this if statement and write a conclusion. And now I can conclude the program. Okay, that'll be the best way. You want to see the other way I was suggesting?
Oh, well, I'm fine with that, but so for I just have a question though. So like if the user inputted 15, 16, and 18, that'd be 0, right? There'd be 0 found.
Right. There will be no
Okay.
no common divisor for those numbers. In that case, it'll say no devices.
All right. It
Yeah.
only prints the smallest one too, right?
Right. Only
Okay.
the smallest. If there are more than one, it will not print the other ones. Only the smallest.
Okay.
That's what the problem says.
All right. Thank you.
Mhm. My solution presented at the end of this may be different. I don't know. You know, there are different ways to do this, and but this would be the best way. All right, so I'll move out of there and move on to today's work, which is, I didn't even open that. The 4.5, you need second half of it, and we'll do that now, part 2 of 4.5. Okay, so let's understand 4.5 part 2, which is about accumulation with user input. So we saw how to add up series. We did one problem from the exercises. So the sums and products we already understood. But in the part 2, we're going to do sums and products with user input. Okay, so Yeah, first we need to understand a operator. It's called arithmetic assignment operator. We have seen in this whole process of accumulations that we have statements like this, n equal to n plus 1. Now we can write that as n plus plus. And then we also have sum equal to sum plus something, a term, something like that. So this plus assignment, equal assignment operator allows you to write this sum equal to sum plus term as sum plus equal to term. Means, so sum plus equal to term means increment sum by term, which is same as saying sum equal to sum plus term. So the plus equal operator, at times it simplifies matters, but it's a matter of convenience. X plus equal to y is same as x equal to x plus y. Increment x by y. And it's an operator that's useful to simplify things, but you don't really have to use it. This not only plus, it also applies to minus and all the arithmetic operators. So you have x minus equal to y, which means x equal to x minus y, and x star equal to y means x equal to x times y. X slash equal to y means x equal to x divide x slash y, division by y. Similarly, modulus equal to means x equal to x modulus equal to y means x equal to x modulus y. So everywhere for all the arithmetic operators, we have that. Now, when it comes to order of precedence, let's go back to order of precedence again. If I write in a program, if I write something like y equal to x plus w times y, you know that addition, the multiplication and subtraction are done before the addition. So this will be done before the addition. After that, the addition will be done. After that, the assignment will be done. This value will be assigned to y as the last step. So the assignment is always the last step. And even if you write, even if it is y equal to y plus x plus w times y, then if you write it as y plus equal to x plus w times y, then same thing happens. The multiplication first and the addition second. This operator will be the last because it's assignment y equal to y plus that number, whatever that number is. So whatever this number is, it will be added to y and placed back in y as the last step, which is obvious because assignment is always the last. The order of precedence, we need to revisit that. Parentheses first, and then the, we already said plus plus minus minus would be, you know exactly with the plus plus and minus minus will be done before any other operation like this. But you know, there is x equal to y plus plus, then plus plus will be done after adding the current y to the x. You know, that's how it works. But if it is x plus minus minus y, then minus minus will be operated only after using current y to calculate x plus y. The current y will be used and then y will be changed. So that is still there. So you don't have to worry about this plus plus minus minus being the second level. That you already understood how that works. So the multiplication, division, and modulus will be the next. After that, subtraction and addition. Only after that, the inequalities will be handled. So let me write a simple example. If I write x plus equal to y plus z greater than or equal to w. I never wrote anything like that. It'll be complicated for you. It would be complicated before this, before we understood these. So now we are understanding. If you write this, normally we write parentheses to make sure the operation will be done in the right order. So if in this expression, which will be done first? Now come look at the table and tell me which will be done first.
The addition.
Y plus Z.
Y plus Z will be done first. That's right. So because addition is done before comparison. This is a valid statement, by the way. On the right side of this equal sign, I have a comparison operation. This is comparison operation, which is valid. And we're comparing Y plus Z to W. Y plus Z will be calculated first, then it will be compared to W. And if it is true, then this whole thing will be true, right? So in this case, Y plus Z is 5 and W is 7, so it's a false. So this whole thing is false. Now false, how do we add that to X? Well, X, let's say X is X as a number. Let me put a number in the X equal to 1. Then this statement now translates to X equal to X plus false, right? The false is a logical value, but X is int, and therefore it'll convert false to int, which is going to be 0. Remember, the false converted to integer will be 0. Only when you convert. It'll be converted here because X is int, and therefore the false needs to be converted. Remember, if there are two operands that are not matching, both of them have to be converted to the larger type. Int is larger than logical value. So therefore, this will be now false, and so X will be X will remain at 1. 0 will be added, so X will remain at 1. So that's how these operations will be handled. So we can have logical inequalities on the right side with plus, minus, and all those arithmetic operations. We never wrote something like that before, but now you can understand how they will be handled. So only after those inequalities, these equal, and not equal logical comparisons will be done, and the arithmetic operators are always the last. Arithmetic assignment operators are always the last because they're same as assignment operators. Assignment operator is the last operation, and so are the arithmetic assignment operators. Okay, so this order of operation you should remember. I mean, the example like the one I just did, you should be able to do in the future. Moving on to next page, we want to do an sum of the, let's say we want to do the sum of the series 2 plus 2 squared, 2 cubed, all the way to 2 to the 10. And I thought we did that. Can we do this?
I don't think we did this.
All right. Okay. Yeah, it doesn't matter. I can quickly go over that. So we need to begin the variable, some variable at 2, and it should go up to 2 to the 10. Now, the problem here is we cannot use 2 to the 10 as a control value. So let me start writing it, then you'll understand what our problem is. Let me move this over. All right, let's start writing. Our value is going to begin at 2. The term I'm adding to the sum is going to be 2. So main begins here, and int n. I'm going to use n to hold that number 2. Let me assign the 2 first. And then the sum is going to have the sum of all those, sum of the series. It's going to start at 0. And while some condition is true, We need to figure out the condition. We'll figure it out later. While the condition is true, I need to add n to sum. So the best way to do that, the series adding, is set your variable to the first one, and then after adding it to sum, change that n to have this. Then after adding that to sum, change it to make it equal to this. So you have to keep changing to go to the next after adding the current one. So that's the idea. So I'm going to add the current one by saying sum equal to sum plus. I can now write it as sum plus equal to n, and then change the n to go to next. How do I change n to go to next? N equal to? Anyone?
N plus 1.
No. How do I go from 2 to 2 squared, 2 squared to 2 cubed? One operation will take care of that.
Oh, sometimes n.
Not sum,
N times N.
and not n times n. No,
N times 2.
You're taking the sum and
n times
multiplying.
2. Someone said that. The n is currently 2. And if you multiply that by 2, you'll get 2 squared. If you multiply that by 2, you'll get 2 cubed. Multiplying by 2 will give you that, right?
But n is not representing the exponent.
No, n is representing the whole thing, the whole term, not exponent. Because just changing exponent cannot be done. Changing exponent can be done, but how do you compute 2 to the power exponent? There is no exponent here. There's no power of operation here.
You could take the sum that you get from the previous execution and then just keep adding 1 to n, which is increasing the exponent. So sum would equal sum times n plus plus, right? And then, then it would rotate, back to the loop and then execute the sum times n plus 1.
No. I know you're getting all math is wrong there. See, sum is going to be, you're adding these 2 plus 2 squared plus 2 cubed. Let me write some of them. Sum will be initially 0, and then sum will be equal to, after you add this, sum will be equal to 2. Right? Sum will be initially 0. After you add the 2, it'll be 2. And then you add 2 squared to it, then sum will be 2 plus 2 squared. Okay?
So
What's the point of multiplying this by a 2?
So then it would be sum plus sum times n.
Wait, Professor, can you give some
on.
the value of 2 and just add 2 squared and then continue from there?
Yeah, you can. Instead
Oh,
of
okay.
starting at sum at 0, you can start at 2, but either way you can make it work. Now let me answer Greg's question. You said sum equal to sum times 2?
A sum equals to sum plus sum times n. And using n as the variable that's changing from 2 to 3 to 4. So yeah, times n plus plus.
Okay, sometimes, and let's think about that. At any point when the sum is equal to, let's say sum equal to this now. You're multiplying that by a 2. Is that what you're doing?
Well, because the first sum after the right of the equal sign has the value of 2. And then I'm adding the 2 times my n, which is equal to 2 right now, the exponent 2. And then if I add a plus plus after the n, then it'll increase that exponent 2 by 3, maintaining the new value of what sum will be. And
Okay.
then
when the sum is holding 2, the very first number,
right.
what you're saying would be 2 plus sum, which is also 2, multiplying by 2.
Right.
That's 2 plus 2 squared. It sounds correct. Okay, when the sum has 2 plus 2 squared, this.
Correct, yes.
When you go to the next step, next iteration of the loop, if you do the same thing here, then you're doing to the 2 plus 2 squared that the sum has, you're adding 2 plus 2 squared times.
No, because the original sum is 2 plus 2 times 2, which is 4, so.
No. Original sum was 2 plus 2 squared. That's what we have in sum right now.
Yeah, but then that would change after the loop. There would be a different value of sum. So
No,
the
No,
sum would,
after the first iteration of the loop, by following your method here, after the first iteration of the loop, sum has this, right?
after the first.
After the first iteration of the loop.
Well, the second then would be 6 though, right? Because 2 plus 4 equals 6.
Yeah, let's keep it as 2 plus 2 squared. It is equal to 6, but let's keep it that way, 2 plus 2 squared. Then to the 2 plus 2 squared, you're adding 2 plus 2 squared times 2 in the second iteration of the loop.
Okay, I see.
Okay,
Times 2 is 4, 4 times 2.
is that giving you the right thing?
Okay, yes.
Is it wrong? I understand.
Yes.
Okay, so that's why we have to do sum plus equal to n, and that right now n is 2, and after adding the n, I'm changing the n to the next. The next one is 2 squared, right? I need to change n to this. So all I need to do is multiply the current value of n by a 2.
Wait, so if the number instead of 2 is like, let's say 3 or 4, so you change it to that, so like n times 3 or 4.
I didn't follow you, Kevin. One more time.
So like you see, it's because like it's 2 to the whatever power, right? So
Uh-huh.
if you change, if instead the question was like 3 to the second power, so you put n times 3.
3 to the second power. No, then the n itself is, the base itself is changing. That's a different story.
No. Yeah. That's what I'm saying. If the base is different, so you multiply by the base.
No, if the base is different, it has a completely different method. Here, the base is same. So from 2 to 2 squared, I can just multiply by 2, right? And 2 squared to 2 to the cube, same thing, just multiply by 2. Just multiplying by another 2 takes you from each term to the other, in this case, right? That's if the base is not changing. If the base is changing, that's a whole different story. If you want, I can do that as a separate problem. It doesn't fall into this.
Well, so for example, if the base was all 4, like 4 to the
Then the
first.
same method will work. N will begin at 4,
Okay,
and you multiply by 4.
Yeah, that's what I was asking.
yeah, that's what I thought he was asking.
That's
Yeah.
what you're asking. If the base is 4 throughout, then the n will begin at 4, and then you keep multiplying it by 4 to get all the other terms. Okay. So right now, I add the n, the current value of n, which is 2, to sum, put it back in sum. After that, n changes to next one, and we do that by n equal to n times 2. This step is to prepare for the next addition, and then you close the loop. That way, after calculating this, you go up here, and if your condition is true, then you add the sum, add the n to sum. Right now it's n squared, 2 squared. You add that to sum, and then n becomes 2 cubed. 2 cubed is, you go back to the top, and if the condition is true, you are adding 2 cubed, and you keep going. So this will be adding all of those, 2 cubed, 2 to the 4, all of those. Now the question is, how do we stop it after 2 to the 10? Ideally, you can write the condition here as, if you can write the condition here in the following way. If there is an exponent operator, we could say while n is less than or equal to 2 to the 10, we need to do this, right? You know what we need to say? The n was 2 initially, then it becomes 2 squared, 2 cubed, and as long as n is less than or equal to 2 to the 10, we need to keep going. When n becomes more than 2 to the 10, we need to stop. So if you can write 2 to the 10, this would be the ideal condition. We can write that, but we cannot write 2 to the 10. Understand me so far? If that would do it, if you can write 2 to the 10. We cannot write 2 to the 10 in C++. That's our problem. All right, if you understand, then I'm going to proceed to take care of that problem. Since we cannot write 2 to the 10, we're going to have to use a different method, which is to eliminate that and keep track of the exponent in another variable. So I need to introduce another variable called pow, and n was initially 2. When n is equal to 2, the power is 1. It is 2 to the 1. So I'm keeping track of the power in this variable. Power is 1. And then as soon as I multiply n by 2, the power has increased. So my power will go up by 1. Then when the power becomes 10, we are done, right? So I need to control by the power. Power less than or equal to 10. As long as the exponent is less than or equal to 10, keep doing it. That's the only way to do it, because we cannot write 2 to the 10 in C++.
Okay, so that's the whole program, right? That's the answer.
That's the whole program right there. Yes. Now there is a way to write power that's coming up in chapter 5. After that, you can use that operation to do this kind of problem. It's a library function. The language itself doesn't have a power, but there's a library function we can use to get power. And after we learn that, you can use that. Okay, so for now, until you learn that, you have to stick with this kind of approach to get around that. Okay, so moving on, I rewrote that. And so let's say we want to add up this series. And here the denominator is changing. So you have to look at the pattern and try to take advantage of the pattern. Think about this. How do we do this? The numerator is not changing, so that we don't need to keep track of that, right? No variable for the numerator. But denominator is initially 2, and then it changes to 2 times 3, and then changes to 2 times 3 times 4, and all the way to 10, where the denominator is getting multiplied by numbers. So we need to keep track of the denominator in a variable, and denominator will be initially 2, and then I need to multiply it by 3 to get the next denominator. Are you following me? I need to multiply current denominator by 3 to get the next one. Then the next denominator should be multiplied by 4 to get the next one. So there's a multiplier which is changing. The multiplier initially is 3 to go from first to second, but from second to third, the multiplier is going up by 1. It's 4. From third to fourth, multiplier by will be going up by another 1. So you need to keep a variable multiplier that changes. Okay, so that's how it works. That's how we should be approaching this. Okay, so let's get a new page. Initially, my variable, so let's begin with the main and introduce our variables. I need a float type. I'm going to make them all float because we have fractions here, obviously. So float, sum is initially 0, and then denominator is initially 2. The first denominator is 2. And the multiplier, I'll call it mult, equal to 3. I need that multiplier to go from first to second term. And the multiplier will have to change also. Okay, so let's see. Yeah, those are the variables I need. So I'm going to, since I don't need the numerator in any variable, these variables will be enough. Okay, so I need to start with the while loop. While we'll come back to the condition.
Multiply is less than or equal to 10.
And we'll get back to it at the end. So first thing I need to do is sum equal to sum plus, which is my sum plus equal to 1 over denominator. The denominator is 2 right now, but it's float. So 1 over denominator will be correctly computed, right? Denominator is float. See, I declared denominator is float. So therefore, this 1 over denominator is fine. So I'm adding 1 over denominator to the sum, and that will be adding 1 over 2. After that, I need to prepare my denominator to go to the next. All right, can somebody tell me what should I do next to prepare the denominator to go to the next?
Increase your multiplier by 1.
No, that's next. Right now, the multiplier has 3. Okay, so how do I get my next denominator ready? What do I do? And that, whatever the operation I do here should work to go from each denominator to the next, right?
Times. So then times mults plus plus.
Yeah, then equal to then times
mults, the multiplier
multiplier, right?
and then plus plus.
And then multiplier should increase afterwards, exactly. And that'll do it, right? Multiplier increases right after that. So if I do that, then close the loop right here. Yeah, I can close the loop.
You can, Professor.
Yeah.
Wait, is that saying that you can increase the entire statement underneath in the denominator?
What do you mean?
Or is it just like one value?
Yeah, no, you can do any number of things you want in the loop. I only needed to, all I needed to do was right after adding 1 over denominator to the sum, I need to prepare the denominator to go to the next. So that's what I'm doing here. My current denominator multiplied by the multiplier will be the correct denominator for the next one, right? So that's what I'm doing. And then afterwards, multiply should increase as a preparation for the next iteration. So all that is done right there. And
Oh, I get it.
okay, so that's all we need. That'll add up the series.
But
But-
what about the value? Like, you see how like in the first value it's just 1 over 2, and the next one, the denominator has like 2 values, and the third has 3 values.
That's what
How do
that's what we're doing. See, look, numbers denominator was 2, right? It was
Yes.
2 initially, and so 1 over 2 is added to the sum right here, right?
Uh-huh.
After that, denominator is multiplied by a 3, so now the denominator is 2 times 3.
Oh, okay. I see.
So in the next iteration of the loop, you're adding 1 over 2 times 3 to the sum.
1 over 2 times 3. Oh, okay.
Okay,
And then what if it were 4?
then the denominator is multiplied by 4.
Oh, okay.
So now the denominator is 2 times 3 times 4. And in the next iteration, you're adding 1 over 2 times 3 times 4 to the sum. Okay.
Okay.
All
I
right
see.
now, okay. So this will add up the series. Now the question is, how do I control the loop? What is the loop control condition? Anybody?
Yeah, well, multiplier is less than equal to 10.
Right, multiplier mult less than or equal to 10. When the multiplier goes over 10, we're done. We have already added everything we need. Right, so while multiplier less than or equal to 10, we need to keep doing it. So as you can see, the series looks complicated, but the program is not. The program is as short as the previous program was.
So if we were to see out sum, right, the sum would be the value of that 10th of the actual, 10th times the denominator. Not 9 times.
When the loop ends, sum has the sum of this entire series.
Okay.
Sum
With
has
the 10.
with the 10, yes.
With the 10, okay.
Yeah, with the 10. This last term has been added, 1 over this last term. When the multiplier is equal to 10, this addition was done. Only when the multiplier becomes 11, the whole process stops. So that means we have added the term with the 10 in the denominator. We have added that.
Got it. Okay.
So see out sum, and that'll do it. That's all you need. Okay, so that finishes that. That's your program there. But what if the question is slightly different and it asks you without, see now in the previous question, it was a finite series like this. It ends when the denominator is multiplied by 10. You're ending it right there. But sometimes it'll be an infinite series instead. And something like this that says you keep adding until the sum goes over 0.7182. See, the sum is going to be a very small number, even though you're adding many things here. The sum is very small number. 1/2 is the first number you're adding to the sum. And what's that? 0.5, isn't it? And next number is 1/2 times 3. That's third of 0.5, right? So it's smaller than 0.5. So all these numbers adding up, they're not going to go over 1, okay, even if after adding all those. So anyway, so let's say the question is this. The series is now infinite, no end to it, but it asks you the question, how many terms of this series should be added for the sum to go over 0.7182? That's our question now. Okay, so series is not ending, it's infinite. So but how many of them should be added for the sum to go 0.7182? If the question is that, then there's a small change we need to make to this program. The program is same as this, but the control is now changing. The control is going to be sum less than or equal to whatever that number is. And also it says how many terms should be added. So that means we need to count how many terms are being added here. So we need a counter. So let's introduce a counter first. Int count equal to 0. You haven't added anything, so count should be 0 before the loop begins. As soon as you add one term to the sum, which is happening right here, the count should go up. So anywhere inside the loop, count plus plus should be inserted, anywhere. That will count how many terms are being added. And then you control the loop by saying sum, as long as sum is less than or equal to 0.7182. Less than or equal to 0.7182, the loop should continue. And when the loop ends, we need to see out count. So not sum, it's count now. The count is what we need. That'll tell you how many terms should be added for the sum to go over 0.7182. Because when the sum goes just over 0.7182, loop will stop. And at that point, the count has your answer, right? So that's what you need to answer that question. All right, so, okay, so let's see if you can write this program. Yeah, all right, we don't need to log into the board for that. Just put it on the chat.
Ah,
Can you check mines, Professor, in the chat?
And you are,
Delon.
okay, I'm checking. No, it's wrong.
Papa, check mine.
Okay, I'm looking,
Ibrahim.
sum equal to d, d equal to no, you're it's wrong. See that the denominators are squares. You're not doing it, Ibrahima. Carlos is almost right, not complete. There's more. Yeah, Carlos is still not complete. Anyone else?
I'm typing on an iPad, Professor, but I'm almost done with mine.
Okay.
Never mind, it just deleted my whole thing.
The denominator is a square of some number, and that number is increasing from 1 to 4 to 7. There's a pattern there on the base. The pattern is on the base, not on the square. The base number.
Wait, were we posting it? Is on the chat?
Yes. We're posting on the chat.
Okay, can you
I
check
will-
mine?
Okay. Okay, I'm checking Kevin, sum less than 1.6. Sum plus 1/6. Right, you got, yeah, Kevin is right. Yeah, you can, everybody can see Kevin's solution, that is correct. Carlos was almost right, and count, yeah, count plus plus, he says count plus plus. That should be inside the loop, which means you need brackets, so the program has to be rewritten. And Oh, okay, Greg has a solution. Let me see. Denominator times power and the denominator. No, okay, Greg, you can't get the exponent by saying then times power. That's not, there's no way of doing exponent. Okay.
Professor, sorry about that. My laptop died.
Okay.
Yeah, this is
Can you plug in? You don't,
yeah, I'm trying to. It's plugging in right now. I just use my phone temporarily.
okay. So, before coming to class, you should have your computer charged up. Okay, so Greg, you understand the problem? You cannot do then times power. You can't get the exponent by multiplying by power. You can get the square by doing then times then. Right? We are only doing square. So that's what you need to do. And Carlos and Kevin have the right solution. So I'm going to, all right, there are three more. All right, now there is correct solution up there. I don't need to check everybody else. So let me, all right, so everybody saw the solution. So the denominator, the 1 is the number initially for the denominator. You can call it denominator or something else, but the 1, the base, that's where you need to control the loop by, the base, because that's changing from 1 to 4 to 7, and there is pattern there. So we can begin by saying float sum equal to 0 and the then equal to 1, and then while sum less than or equal to, you should say less than or equal to 1.6, because when it goes over, we need to stop, not when it is equal to 1.6. So therefore, as long as sum is less than or equal to 1.6, you should keep going. And what do we need to do inside? We need to add 1 over then square, then times then. Then that'll be square of the current number. The current number is 1. So it's 1 squared being 1 over 1 squared is added to the sum. And immediately after that, the then should change to go to the next denominator. The base number then is changing from 1 to 4 to 7, which is just adding 3. Just adding 3 will take you to the next one. And also introduce the counter, int count equal to 0. And then increment the counter here. And you'll be done. And see out count when the loop ends. Okay, so very good. Moving on. Okay, now let me use this example to, the next example is actually about accuracy. So let me use this example itself to introduce that. Suppose that the problem here says how many terms should be added up to get the sum to go over 1.6. Now, instead of saying 1.6, if it says how many terms should be added up for the sum to be accurate to 3 decimal digits, then the control is going to be slightly different. And I'm going to explain that. So we are adding up the infinite series. Accuracy of the answer should be 3 decimal digits. 3 decimal digit answer should be obtained. And we don't need to add any more after getting 3 decimal accuracy. So can you see that the numbers are going down as you proceed? The first number is 1 in the series. The second number is 1 over 16. which is very small number, 1/16, 0.025. The next number is even smaller. So when you add the second number, 0.025, very small number, it's something, I don't need to calculate that. It's something like 0.001 something, the very second number. Next one is 1/49. 1/7 squared is 1/49, which is even smaller. So as you proceed to add these up, if the number is really small, then it may not change the first 3 digits. So when the number is too small to change the first 3 digits, you only have 3-digit accuracy. Understand what I mean? Because everything after that will be smaller than this number. So so if I'm adding, if a problem says we need 3-digit accuracy and we need to stop adding up when we have 3-digit accuracy, then what we need to do is this. When the term here is, first term is 1/1 squared, second term is 1/4 squared, third term is 1/7 squared. You keep adding these terms. When the term is simply, too small means first 3 digits will be 0, and even next digit is 0, and the following digit is a 5 or less than that, 5, then adding this number will not change the first 3 digits of the sum. If the sum already has 0.3757, then if you add 0.0005, that will change the 3 digits, right? If you add 0.0005. If you add something smaller than that, yeah, so it needs to be 0.0005. If the term is smaller than this, then adding that will not affect the first 3 digits. Understand? If the term is smaller than this. So if the problem says we need to add up this infinite series accurate to 3 decimal digits, then your condition is our term, when the term is smaller than this number, first 3 digits are 0, and the next digit is 5. And even if you want to be even more careful, you can even make that a 1. If it is smaller than 0.0001, then adding this will not change the 3 digits that we have, which means we only have 3-digit accuracy. That's how you do that. So if I'm doing that for this problem, for the above problem, then the change, so what I need to do is, the changes I need to do are the following. I need to, so let me erase these. So the problem says we need 3 decimal accuracy in this case. The sum doesn't have to be less than or equal to 1.6. The sum should be accurate to 3 decimal digits. Then I have to specifically calculate the denominator, the term, and store it in a variable term. And so I need to do this up here before the loop begins. I need to say term term equal to 1/denominator. I need to introduce the variable term, and that's 1/denominator. Or term is 1/denominator is 1/1, which is 1. So I can just set it to 1 initially before the loop begins. And then in here, what I need to do is in the loop, I have to calculate the term. And then, so the way I have written it here, sum equal to sum plus 1/10 times 10, I had to eliminate that. and calculate the 1 over 10 times 10 and put it in the variable called term. The term, this expression, each term has to be calculated because the term is what we are going to compare to 0.0001. So I had to separate this addition part into 2 steps. So I'm going to erase this line, sum equal to sum plus 1 over 10 times 10. I'm going to erase that and say 1 over term, sum plus term. Term is right now 1. So I add that term and then increment the denominator and calculate the next term. Calculate the next term right here. Okay, erase all these and term equal to so I had to explicitly calculate the next term and put it in the variable term. Term equal to 1 over 10 times 10. 1 over denominator squared is calculated and stored in term, and increment the counter. We also need the count. We don't need the counter anymore, not for this question. It's not asking for the number of terms to be added. It's asking for the sum of the series accurate to 3 decimal digits. That's our question now. Okay, what is the sum of this infinite series accurate to 3 decimal digits? To achieve that, I can eliminate the counter. I don't need to count. I just simply have to calculate the 1 over denominator and store it in term and close the loop. And then up here in the loop control, the term has to be significant enough to proceed to add. So I need to say while term is greater than or equal to 0.0005. That's how we need to write. 1 would be better, 0.0001. 0.0001. If the term becomes smaller than this, we can stop, because adding such small term will not change the 3 digits. So while term is greater than or equal to 0.001, add the term to sum, and then calculate the new term. And then go to the top. If the term is still bigger than 0.001, then add it to the sum, change the denominator to calculate term, new term. And then, so after each term is calculated, you're going to the top, and only if that term is big enough, you're adding it. So at some point, the term will be too small to add, and the loop will terminate. At that point, your sum is all done. So you write the sum. That's how you handle accuracy. It's a common problem in engineering. You know, some things have to be added up to get certain accuracy. So it's an infinite series. You need to add up as many as you can, but if the term becomes too small, we can stop, which means if you already have 3-digit accuracy, we can stop. That's what we're doing here. When we have 3-digit accuracy, the term, when the term will be smaller than 0.0001, and we stop at that point and write the sum. All right, so that finishes that. And now we are going into a new topic. And so let's take a break now. It's 10:49. So 10:55, so we'll begin at 10:55.
Professor?
Yeah.
I'm required to go to school, like to get tested at a certain time by the health department.
Mm-hmm.
And
Today?
it's in an hour. I can stay until like 11, but I have to get to school by 12. That's why, to get the tested. They're like making it mandatory for, because I got exposed, so I have to get tested at a CUNY site at school at like a certain time. That's what the health department is doing for is requiring me to do during yeah, basically, yeah.
And it has to be 12
Yeah.
at a time?
No, because I also have to do, because it's not just the health department, the athletic department and the health department are making me do it. But like we also have to do it, like the team has to do it at the same time because we were all exposed to it, you know?
Okay,
Sorry, Professor.
all right, yeah, whatever you miss, you're on your own to study that.
Okay. These slides will be posted, right?
Yeah, I'm recording today, so I can post it.
Will it be upload? I mean, I understand most of it for the, yeah, so I should be fine. But our test is tomorrow, just to make sure, right?
Yes.
The first section or the last section? Usually it's always a later section, right?
Always at the end, yes.
Okay.
From 11 on.
From 11?
Yeah.
Okay. Thank you.
Mhm.
Professor, my laptop is back on. I'm going to be using it to sign in.
Okay,
It just says waiting for you to let me in.
all right.
Got it. Thank you.
All right, you're back. So the next topic is, this is still 4.5. We are going to be accumulating with data entered by user. So we're not adding up series. Instead, we're going to add up numbers entered by user, or add up or multiply up, various things. But we're going to work with the user entered data. So we're going to, let's say the user has certain number of data that he's going to enter, and we're going to multiply up or add up or whatever we need to do with it. We're going to do some operation with it. And the question is, how do we control the loop? There are two ways. One is if the user knows the count of the data. So user knows there are 100 data or 150 data, then the user can tell us how many data are there. Because our loop has to execute as many times as the user has data. The loop has to keep going as long as there's more data. So if the user can tell us how many data are there, then we can make sure the loop goes that many times, asking for that many data, and it'll process that many data. But the user may not know how many data he or she has. So we have to consider both all those situations and work with the data that the user has. So that's our goal. The first method is called counter control accumulation. The program will be written to get data from user a certain number of times, because the user has only a certain number of data. So if the user has 50 data, and if he or she can tell us that, then we can make sure the loop goes 50 times, getting the 50 data, and then process whatever the processing we need to do. And the other one is called Sentinel controlled accumulation, and we'll get to that in a minute. So let's look at the counter controlled accumulation. We're using an example. The grades of students in a class will be entered by the user, and we need to write a program that obtains the number of grades first, and then the grades themselves. So first, I'll ask the user to enter the number of grades. And after I get that, I'll then ask the user to enter the grade one at a time. So only one data will be stored in the storage or memory at any one time. And we do the processing of that data and then ask for the next data. The next data will go into the same variable. So I'm going to build the program on the board instead of showing you the program. The program is going to keep asking for the data. First, it will ask for the number of data, and then we will make sure the loop will keep going that many times, asking for that many data. So here's how we do that. Let me adjust this a little bit. Okay. So our program can begin with the main here, and we're going to introduce a variable int I'll use the variable size for storing the class size, actually. And then I also need a counter. The counter is going to count how many data we have obtained so far. That's a different counter. So size is going to be class size, the size of data that the user has. And the count will begin at 0. And then we will ask the user to enter the size, class size. Enter class size. Or you can say enter the number of data you have, whatever you can ask the question in different ways, and then see in size. So the class size is now ready. That means we know how many data user has, and we need to make sure our loop goes that many times asking for the data. So we're going to ask for the data from the user, but we only ask for the data this many times, whatever this number is. And then we'll say, let's say we are finding average. Then let me go up here and introduce the variable float sum. Will be 0 initially, and we are going to find average. So av is the variable for that. And I got the size of the class. So my while loop begins here, and I'll put the condition later. Inside the while loop, I need to ask for the user for the data. See, the user is going to enter a certain number of data, and we need to get those data and add them up. So enter data or enter grade, whatever you want to say is fine. Cin float, go back to the float list and add grade. Grade is the variable that's going to hold the grade. So read the grade into the variable grade, and then increment the counter. The counter was 0. As soon as I get the first grade, counter becomes 1. And the counter will go up after getting each grade. So this loop will repeat. So as you can see, when the program runs, it'll ask for the data, and the user will enter the first grade he has, and counter goes up 1, and then it loops back and asks for the data again, and the user enters the next data. The next data goes into the same variable grade, replacing the current value of grade. So grade has the new grade now, and then I need to do whatever I need to do with that, and then increment the counter. So I'm getting the grades, but I'm not doing anything with it. So I need to add that term. So go back and erase this. And what are we doing with the grades? We are going to find average, so we need to add them up. So I can say inside the loop, I can say sum equal to sum plus, or sum plus equal to grade. That'll add the grade to sum, and put the result back in sum. And I don't know why this does this. Grade, add the grade to sum and close the loop. So when you enter the loop first time, it'll ask for the first grade, and you get that in the variable grade, and add that grade to sum, and then it loops back and asks for the next grade. You get the next grade in the same variable grade, erasing the previous grade. So this way, you're only having the latest grade entered by the user in the variable grade, and you're adding that to sum. This process goes on. It should go on while what is true. Can somebody tell me, when should I stop the loop? While what condition is true, the loop should continue.
The number is higher than the grade.
What is higher than the grade?
The CN.
When the count is less than the size.
Count is less than or equal to size, right? The count is counting how many data we have already gotten. And when the count reaches size, we should stop, because the size is the number of data user has. So if the size is 50, the count goes from 0 to 1, 2, 3. When count reaches 50, we need to stop. There's no more data. So when the loop stops, we have already added up all the grades. And so here we can find the average. Average equal to sum divided by size, class size, and then see out average. So that tells you how to do this. Now notice that the variable grade has one grade at a time. The latest grade entered by the user. That's what we have in the variable grade. We don't have all the grades available when everything finishes. When everything finishes, the variable grade has the last grade entered. Okay, so we don't have all the numbers stored anywhere. If you need to store all the numbers in some way, we have a way, and that's coming up in chapter 6. Until then, we have no way of storing all the data. So as of now, this is all you have. So in all your programs or in the next programming project, you need to get the data one at a time and do all the processing of the data like I'm doing here. So this method I have used here is appropriate only if the user has the count of the data available, which is in this case the size, if the user has the size available. Okay, so the next question. So that program is written right there in your presentation, and also it's in the book. Now, if you run that program, the communication with the user will go this way. Enter the class size. So the user will enter the class size, and then it'll ask for the grade, and the user will enter one grade, and then it'll ask for the next one. User enters next grade, and you keep going. And then when the user has already entered 10 data, the answer will be written, because that's what the program is doing. The average will be written. Okay, so yeah, okay, so slightly, this question is slightly different. Write a program to obtain the class size and the grades of students in the class and print how many are passing the test. The passing grade is 60. So you need to count how many students are passing the test. Okay, so go ahead and write that program. To minimize your typing, you don't even have to declare the variables. You can begin with the body of the program. No main, no declarations, just write the body. Notice that you still need to get the size of the class to control the loop. And you still need a counter to count all the data entered. So pretty much the program has to have everything I have in this previous program. You need one more counter. You need an additional counter. Why? Because you need to count how many are passing the test. So that should be a separate counter. the program structure will be very much like the one I wrote. It's still on the board. The only difference is the processing. The processing processing I did in that program was adding them up. The processing you need to do is determine whether each grade is passing grade or not. There is nothing in the chat yet. All right, there is one in the chat from Greg. Right, okay, Greg has the right program. All right, yeah, so there's one program, correct one on the board, so there's no reason to wait for the others. I'm still going to write the modification to this. So what I have on the board is still a good program for this purpose. The only difference is I need to count how many students are passing. So I need to introduce a variable for that, and I'm going to do that. So in my declaration, I need to add another variable, PCNT, to mean pass count, and set it to 0. And the processing of the data, everything else the same. The processing of the data is going to be not adding up. Instead, we are doing something else. So I'm going to write that part. Only difference is, other than that, everything else is going to be same as what I have written here. So I need to say if grade is greater than or equal to 60, then p count plus plus. That's all I need to add. That's the only processing I need to do. Everything else is same. So erase the average calculation. And I need to print the p count, the pass count. When the whole thing finishes, print p count, and that'll be it. So that's all you need to do in that program. So all of the programs involving counter control loop will be exact same thing. Only this processing part changes. This part changes. Other than that, it's the same structure. If it is counter control. The counter control loop applies only when the user has the count. He or she will have to enter that first. But the users of the program normally don't want to count the data because the data are often hundreds of thousands. If it is a statistical analysis you're doing, then you will expect to get hundreds of thousands of data, which the users don't want to count. So they are willing to enter the data one at a time. That's all they will do. And your program has to do the counting. So how do we do that? That's what the Sentinel control loop is about, Sentinel control accumulation. In this method, what we do is we don't have the count available. The user doesn't have the count. So what we will do is we'll keep asking the user to enter the data as long as the data exists and as long as there is more data. And when there is no more data, the user will enter something that will indicate finish of entering the data. So something that will indicate no more data. So we call that number or character that the user will enter at the end, the Sentinel. Sentinel will indicate that the user is finished entering the data, and we are done getting the data, and we just need to process it. So the Sentinel can be some number that is that will not be equal to data. So for example, if it is grades we are working with, like the previous program, then we know the grade cannot be -1. So therefore, we can ask the user to enter a negative. You have to tell the user what your Sentinel is. So we can ask the user to enter -1 when he or she is finished entering data. Okay, so we will keep asking for data as long as that data is not -1 and keep processing it. When the data is -1, we'll stop the loop. That's called Sentinel control loop. So let's write the program of getting the grades of students for a test and then calculate the average grades. Let's do that same program, calculating average grade, but this time user doesn't have the count. So we have to use a Sentinel. Now Sentinel is something you, the programmer, decides. And then you tell the user to enter that when he or she is finished entering the actual data. So you have to make sure your loop will continue as long as the data entered is not equal to Sentinel. When the data is equal to Sentinel, your loop should stop. And also one other thing you need to remember is when the user enters the Sentinel should not be processed. The processing we are doing here is adding up the data, adding up the grades. So the Sentinel should not be added up. And so you need to write the loop so that these matters are taken care of. Okay, so that's very important. If you write it the wrong way, if you write the loop in the wrong way, some statements are in the wrong order, then you may end up processing the Sentinel, which is wrong. So here is the best way to write the loop is the one I'm going to be writing on the board, and try to use the same structure in your programs, in your homework questions, in your project, everywhere. Try to use the same structure. All right. Yeah.
So real quick, with this, the Sentinel control loop, the loop ends when the user inputs -1.
Right.
Okay.
Right. So we're going to write the loop so that in such a way that it will terminate when the data is -1. Okay. All right. So to do that, I begin the main. I declare. So I'm writing the grade program again using Sentinel control loop. So float grade. And I'm going to be calculating the average. So and I also need to count the data because the user is not going to give me the count. So I had to count the data. So int count, and that's all I need. The variable grade will hold one grade at a time. As soon as we finish processing the grade, we will erase it and put the next grade in. Now, in this Sentinel control loop, I need to say the loop should be controlled this way. While grade is not equal to -1. That's how you control the loop. The grade should, as long as grade is not -1, we need to get a grade and process, right? So the best way to, if I write this condition, grade not equal to -1, that means grade must have a value, right? So otherwise this loop will never start. So grade has to have a value for this condition to be checked. And therefore, the best way to do this is to get the first grade before the loop begins. Up here, ask for the first grade. Enter grade. and cin grade. So you have the first grade entered by the user stored in the variable grade. And now this condition can be checked. While grade is not -1, you begin the loop. Inside the loop, the first statement you write should be processing the grade that we already have. We have one grade already. So I process that. What is the processing I need to do? In this case, just add it to the sum. So sum plus equal to grade. That's only the processing. Whatever, all the processing you need to do with that grade, you need to do here. And when you're finished processing, you need to ask for the next grade. So only after the processing is done. So I also need to increment the counter. So the count plus plus can be anywhere inside the loop. It has to be inside the loop. Count should be 0 up here. You need to set it to 0. When you say increment counter, the counter must have a value to begin with. So that's why you need to put a 0 there and increment it. And the next thing, I'm finished processing. So I need to ask for the next grade. Enter grade. And this is where you need to say -1, enter -1 when finished entering the actual grade. -1 when finished. Something like that. You need to tell the user what to enter when he is finished entering the grade. And cin grade. So this is the best arrangement. Now notice that I close the loop here, which means as soon as I get the new grade, I go to the top and compare it to -1. Only if it is not -1, I'm adding it to sum. See that? That's why this is the best arrangement. The very first grade I get before the loop begins will be added to the grade. We assume that that's not -1. Add to the sum. But the very first grade is added. After that, count goes up to 1. And now we are getting the second grade. And the second grade is going into the variable grade, erasing the previous one. And with that grade, we go to the top and check to see if it is -1. If it is not -1, we add it, count it, and then ask for a new grade, get the next one. The process continues as long as grade is not -1. When the user enters a -1, which will happen here, -1, I go to the top, the grade is -1, loop stops. See that? I'm not adding the -1. Everybody see that?
How would the user know that though?
I'm sorry?
How would the user know to enter -1?
That's what I'm saying in the parentheses. Whenever I say enter grade, I'm saying enter -1 when you're finished entering grade.
Ah, okay, got it.
That's what I said here. So that way user will know that he or she is supposed to enter -1 when there is no more grade. So whenever the user enters -1, the variable -1 goes into grade, and then the loop stops because the loop condition says as long as grade is not -1, proceed. So the -1 is not added to the sum, and this is the right way. And when the loop ends, you can say average equal to grade over count. The count has the count of the grades entered. So you divide by count and then see out. You can do all the, you can do any processing you need to do, you do before this see out. Before this see out, this is where you need to do all the processing. I only needed to add it to sum, but if you need to do other things, you can do that. So let's say, for example, I also need to find the lowest grade entered. Okay, then what do we need to do? We need to add one more thing. So right now this program is complete for the goal of finding the average grade. But if I also need to find the minimum grade, then I can throw in some variables. So go back and add min as a variable. And as soon as I get the first grade, I copy the first grade into min before the loop begins. And then inside the loop, as after getting each new grade, I need to say if in here, after getting each new grade, it'll go to the top. And if the grade is not -1, we'll be starting to process. The processing part now includes if the new grade is smaller than min, then the min should copy the new grade. If I just throw that in, that's enough. Every time after getting new grade, the new grade will be compared to the lowest number we have so far. And if it is smaller than lowest, then it will be copied into min. Otherwise, it will be ignored. So that will keep track of the min. And down here, see out av endl min. We print the minimum if you need. And so all the processing you need can be done within that part. So you'll be doing in your project, you'll be finding sum and minimum and all those maximum. If you need to throw in, if you need to find maximum, then throw in a variable max and same thing, just add another if inside, that'll take care of the maximum part. Okay, so let's proceed. And so here is the same program written here. Notice that I'm getting the first grade before the loop begins, so that we compare that grade to -1 to begin. And then the first statement inside the loop is adding that first grade that I got before the loop begins. Processing, all the processing of that grade should be done here. And only when the processing is finished, you ask for the next grade down here. Okay, suppose that, one question. Something you need for your project. I'm going to give you the idea right here. Suppose that you want to, you need to keep more than one grade because you also need to find out how the grade changed from previous to the new one, okay, the change. So if you need to calculate the change of the grade from the previous grade to the new one, which is not appropriate for the grades, but for your project, it's appropriate. So let me explain that. So then we need to keep 2 grades at any time to be able to calculate the difference, right? So the way we have written it, we only keep 1 grade at a time, right? So if you need to keep 2 grades at any one point, then you can do this. Right before this line, P grade, to mean previous grade, equal to grade. And if you throw that in, then before getting the new grade, the previous grade is stored in the P grade. Whatever the grade you have processed is copied into P grade. After that, you're asking for the next grade and getting the next grade into grade. So at this point, you have 2 grades available, previous and the new, right? So if you want to calculate the change between those 2 grades, you can do that here. Change equal to P grade minus grade. Right there, it's appropriate to do that. But actually, you shouldn't do that here because the grade could be -1, right? So instead, I would take it out of there and put it up here. Why? Only if grade is not -1, you should do that. Only if the latest grade entered is not -1, right? If the latest grade entered is -1, then you have already computed all the changes. And so you should not work with the -1 at all, right? So that's why the processing should be done after checking the grade against -1. So if you do that, then one question comes up. then the P grade doesn't have any value at first, right? When you enter the loop first time, P grade doesn't have a value, see that? Okay, then what we can do is, after getting the very first grade, P grade equal to grade. So P grade is same as grade when you enter the first time. And then the change will be 0 for the first time. That's okay. The change is 0. Because when you enter the loop first time, you only have one grade available so far, right? So the change being 0 is okay at that point. But after that, you're going to get the next grade. You're going to get the next grade here. At this point, you have 2 grades. So when you go back to the top of the loop, as long as the new grade is not -1, now the change is actually the change between 2 grades. Agree with that? During second iteration, your change is correct. First iteration, change will be 0. That's okay. It is acceptable because when you enter the loop first time, you only have one grade actually available, so there is no change. So this is a good approach to have the 2 numbers available, or if you need to calculate the change between them, that's one way to do it. And then how you use that number to process your to do all your processes is up to you. I just gave you the idea of how to have 2 grades available at any one point. That's how you do that. That's something you need to do in your project. All right. So this lecture is being recorded, and I will be posting the recording, and so you can refer to that if you need to. All right. So this is an alternate way to write that program. If you don't want to get the first grade before the loop begins, if you want to do without doing that, then you can store a dummy value 0 in the grade to begin with. This is another way to handle it, but it's not the best way. The way I have shown you so far, that's the best way. Getting first grade before the loop begins and getting the next grade at the bottom of the loop, like on the board, like we see on the board, let me go back to the previous page. The program written here, getting the first grade before the loop begins up here, and then processing it in the middle of the loop, and then getting the next grade at the bottom again, asking for the next grade at the bottom. That's the best way. Okay, everything works perfectly fine if you approach it that way. Now this other method I'm suggesting is put a dummy value 0 in the grade so that this condition can be checked. After that, you get the first data here. And ask for the first data here, and you get the first data, and you add up, add to the sum, and increment the counter, and then go back to the top. If the last grade entered is not -1, then you ask for a new grade. The problem is, if you do that, when the user enters -1, that goes into grade, and that -1 is being added here. See that? So that's not good. But we can make an adjustment for that by adding a +1 to sum at the end. Then you're adjusting to the -1 that was added, right? There was a -1 added, so if you add a +1, you balance that out. So in a way, this is correct now, after I made the adjustment. But this is not considered to be a good way, because this will be confusing a reader, because why is this 1 being added? Unless the reader is very careful, he wouldn't understand what that 1 added here is. So it's making it unnecessarily complicated, and also making it difficult to read for a reader. And therefore, this is not a recommended approach, using this dummy value 0 to make the loop start. But no matter how much I say, the students tend to forget this method and try to do their own, and almost always end up doing it wrong. So please remember, whenever you are processing data entered by user, and you're going to use Sentinel control loop. If the count is not available, if you're going to use Sentinel control loop, this is the best way to learn, the way I have arranged it here. And try to use that same thing, you won't go wrong. Otherwise, you can go wrong with your method. So please don't do that. Okay, so let's do this exercise.
Professor?
Yeah.
Yeah, can I use the bathroom real quickly?
Okay, I gave you a break to do that.
I understand.
All
I
right.
just want to know, like, would this be uploaded so I can review it?
Yeah, I'm recording it, so I will upload it. Now, remember, I won't be able to immediately do that because there is all kind of processing the computer has to do. As soon as I finish the meeting, it will say processing, and it will say that for an hour because it takes a long time for the system to process that. And when the processing is finished, I have to upload it to the YouTube, and YouTube has its own processing, right? So
Wow.
other processing starts. And so that's why it takes so long, all right? So I cannot, it's not me, it's the system. So it'll be a while before I put it up, but I'll put it up.
All right, thanks, Professor.
You're welcome. The problem here says, write a C++ program that uses Sentinel control loop to continuously obtain float type numbers from the user until a 0 is entered. So it's suggesting 0 as the Sentinel. Multiply together only the positive numbers entered. So we need to multiply the positive numbers entered. Okay, so let me see if you can write that. I'll give you 2 minutes. And, we don't have much time, so 2 minutes is all we can do. You don't have to declare variables, just write the body of the program.
Professor, did I get the exercise right in the chat?
Okay, let me check. Okay, I have okay, I have one from. I'm checking all of them. Hold on. I have one from Minju Kim. So let me check. I'm not equal to 0. If greater than 0, then multiply. Right, very good. Minju has the right answer. Delon, num, while num is not 0. Sum equal to num times num. Then you're replacing sum with the square of the num. Is that what we want to do? No, that we don't need to do square. No, that's not correct. Greg says num not equal to 0 if num modulus 2. No, Greg, you seem to be doing wrong problem. We are not doing it. There's nothing about even odd. Okay. There's nothing about even odd. So that's wrong. Okay, so we only need to multiply up all the positive numbers entered. That's all we're doing. That's all the processing. All right, so I'm writing the program on the board. So the first number I got from the user is stored in num. And now I need to say while num is not 0. While this number entered by the user is not 0, not equal to Sentinel, I need to process it. The processing will be if num is greater than 0, then prod equal to prod times, which is same as prod times equal to num. Just multiply prod and num, and that's all the processing I need to do. Only if it is positive, I multiply, otherwise ignore it. And then I have to go ahead and ask for the next one. See out, enter number. And this is where I need to say -1, enter -1 when finished, all that. And then see in num and close the loop. After getting each number, you need to go to the top and check to see if it is not 0. If it is not 0, then multiply prod by num and proceed to the next. So that'll do it. And when the loop finishes, you see out the prod. Okay, that finishes section 4.5. All right, section 4.5 is the most difficult part, in my opinion. But it looks like, most of you got it. As always, there are few students who cannot understand the loop idea very much. And, but it looks like most of you got it. So I'm glad that's the way it is. So let me go ahead and start my next topic, which is function. This is chapter 5 in your book, and we need to do chapter 5 and chapter 6 to finish. So we have very little time right now, kind of tight schedule for the 2 chapters we haven't completed. But I have to try and finish that. So let's see. Let's understand functions. So everything we have done are necessary tools for programming. The chapter 6 is also a necessary tool. The function is a helpful tool. It's not necessary tool, but it is helpful to write your program better in a better way. And also one thing important is function library is something that we can all use, all programmers can use. For that reason, the functions are important topic to understand. Only if you understand functions, you'll be able to use programs written by others that are placed in libraries. You can pull those and use them in your program. And we're going to learn all that in this section. First, we're going to have to learn to write our own functions, and that's what I'm going to be in. A function is basically a way to break up your program into subtasks. So within a task, there are subtasks that can be isolated into separate programs. And those separate programs are called the functions. So a subtask means, for example, suppose that you're writing a long program in which there are several places where you need to solve different quadratic equations, let's say. Then if you write separate program to solve quadratic equation, then whenever you need to solve a quadratic equation, you can call that separate routine. Go there and do this, and then come back and proceed. And then when you need to solve another quadratic equation, you can now say, go there to that quadratic solving process, do that and come back. And so that's what we call calling a function. You write a call statement to the function, it'll go there and do everything there, come back to the same place and proceed. So if you need to do the same thing over and over in a program, then it makes sense to isolate that as a function, as a separate routine. And then call that function whenever you need to use the service of that function. You can call it as many times as you need. And that is a powerful idea. And that generated this function idea after they introduced that in the language. Other programmers started there writing the functions that are important for common tasks. And they created a library of functions that we can all use. We can use those libraries to achieve that. So one of those is the exponent. Remember, in the language, there's no exponent. So someone has written a function that will find exponent, and now we can use that. We can all use that to find exponents. And that's an example. So using library function is another important result of the idea of functions. Okay, so this subtask, we can isolate the subtask and separately write a function, write a program, which we call function. And then in the main program, we can refer to the function whenever you need to. We call it calling the function. So let's understand how to write the function first, and then we will we'll write some functions of our own, and then we will, in the next section, in the third section, we will learn how to use functions written by others. Whenever we need to work with a long programming task, it is recommended that you subdivide the task into smaller subtasks. And the advantage is the subtask can be called many times as you need. So these subtasks will be written as a separate routine, which we call function. Okay, so the function would be called within the main program whenever it needs the help of the function. And that statement that calls the function is called function call. And we will learn the function calls in the section 5.2. In section 5.1, we will define our function. You'll learn how to write the functions. So defining our function is going to be this. You write a function header. Like in the main program, the word main is the header. And in the function, the header will be slightly different. And you write the header and then curly bracket. And then you write all the statements that will do the job of the function. And then close with the curly bracket. That's how you write the function. Now the function header will have a name. A name for the function, you must make up a name that is appropriate for whatever it's doing. And so here is an example of a function. This function is going to write text. The text it will write will be this: the Wonderland. and then it'll underline it with asterisks. That's all this function is going to be doing. And therefore, I'm calling this function write text. That's the header. And then curly bracket, and then cout a tab, and then the Wonderland, ENDL, and then on the next line, tab over and write asterisks so that the title, the Wonderland, and the asterisk will line up. One, it will be one below the other. And so the output will be this. And that's what this function will do. And that's all it's doing. So this is a function. So if you call this function within the main anytime, it'll write those 2 lines of text. That's all it'll do. And you can call it as many times as you want. Every time it'll write that 2-line text.
Yes, sir.
Yeah.
Does the function, is it written before the main?
Yes,
or
the
okay.
actual program file, you will write the function at the top, right after the pound include and the using namespace std. Then the very next thing is the function. And after ending this bracket, ending the function with that bracket, you begin the main. After that bracket, you begin main. That's how you normally place.
Okay, thank you.
If you, you can actually place the entire function at the bottom of the program, then you have to write something at the top. We'll discuss all that later. But if you put it at the top, then there's nothing else to say. It'll recognize the function if you put it at the top.
So as you're writing your program, if you come across something that you realize can be set as a function, then you would have to go back to the beginning of the program to
Right.
state that function?
Yes. You have to go to the top of the program and put that function in. So let's practice writing the functions next. So as you can see in the header of the function, we have a name for the function and then empty parentheses. The parentheses is empty right now, but the parentheses will be used in certain circumstances. We'll understand all that later. But you need an empty parentheses anytime you write the function. If you don't write the empty parentheses, it will try to interpret your write text as a variable or something. And if it doesn't qualify to be a variable, you'll get error message. So the empty parentheses makes that a header of the function. So that's necessary. The parentheses next to the name of the function is necessary. Okay, let's proceed. This function, write text, is the purpose of that function is to write the 2-line text. So it's not finding any answer that it needs to return to the main. Very commonly, functions will find an answer and it will return that answer to the main program. So the purpose of the function is to do something and return an answer. So there will be a return value in most cases. This function doesn't have any return value because the job it needs to do is just write text. It doesn't need to return anything to the main. Some other functions will be returning something. So if the function is returning something, then the data type of the returned value is called the data type of the function. So if it is returning an int type value, then the data type of the function is int. If it is returning a float type value, then the data type of the function is float. And that data type has to go in front of the name of the function. In front of the name, the data type should be put in. So that's part of the header. But this function is not returning anything. So what is the data type of this function? If the function doesn't return anything, then the data type is void. Void is the data type. So I really need to say void here. That's necessary in the header. Part of the header is the data type. Void should be there. I didn't place that because I didn't explain that before. So it is necessary to put the data type of the function. Data type of the function is the data type of the value it will return to the main. Andrews, I don't think you're paying attention. You're being distracted. Andrew, are you with us? I think you're distracted with something. Andrews,
Yes.
I think you're distracted. You're not with us. Are you following us?
No, I'm actually lost in the process here. So I was just like looking through the textbook. So
So you're not in the meeting.
I am in the meeting. I'm just like not following because I'm scrolling through a textbook.
So are you back? Are you going to continue now?
Yes, I'm catching up.
Professor, I have a quick question.
All right. Yeah, go ahead.
If I wanted to utilize this function, like the purpose of it, like anywhere in the program, I wanted to write the Wonderland with all those asterisks in it, then I would just put void write text and then.
No. That would be a function call. I'll explain function call later. Okay, in the main program, how do you call a function? That's coming up.
Okay.
In 5.2. Here, we're going to just focus on writing our functions right now. So when you're writing the function, you need to put the void. When you're calling the function, you don't. Okay, you call the function by name, but we'll be doing that later. Only when you write the function, the header of the function, which is the very first line before the bracket, must have a name for the function and a data type of the value it will be returning. In this case, is void. And then you have the body of the function and then end it with the bracket. That's
Professor?
all. Yeah.
Can you explain what void represents? Like what is that?
The void says this function doesn't return anything.
Okay.
Okay. If the function is returning anything, then the data type of the value it will be returning will be going there. That'll be an int or a float or a char, some data type will go there. This function doesn't send anything back to the main. Its job is just to write a text. And that's why this function is void. It doesn't send back anything to the main. That's what it means. All right, everybody got that? Any question? Feel free to ask. Okay, so there will be a data type in front of the name like this. If I'm writing a function that will find maximum of several numbers received, it receives several numbers and find largest of those numbers, and it will return the largest number to the main. If that's what your function is doing, then we can call it find max, and the data type will be float because it will be returning a float type number, which is the largest number. Okay. And function write text is not returning anything, so therefore it's a void type. The data type should go as part of the header. Okay, so let's write the function find max. The function find max we are going to write will receive two numbers, and it will find the larger one of those, and it will return that to the main. It will send that to the main. Okay. So we say that this function will find an answer and it will return that to the main program. So the header of the function will be float, find max. And then I said earlier, our parentheses was empty, right? Our parentheses will remain empty if the function is not going to receive anything from the main. So function write text didn't have to receive anything from the main to do the job. And that's why the parentheses was empty. But this function is going to find larger one of the two numbers. So two numbers have to be received. And that's when you write two variables in the parentheses. It's these two variables that will receive the values. So whatever the function is sending will be received in these two names. Andrews, are you with us? I don't know what you are reading some jokes or something. You are not really here. You are laughing.
Oh, no. I'm just keeping myself.
There's nothing funny about these functions that you are laughing about, right?
No, it's just.
I just want your attention on this. I think you're getting distracted. All right, so if the function is going to receive some numbers from the main program to do the job, then the received numbers will be in the to receive numbers, you need to have variables inside the parentheses, and they should be declared. So here I have declared float num1, comma float num2. You cannot write float num1, comma num2. Individually, each one has to be declared. And what are these for? These are for receiving two numbers from the main. And then these two numbers, among these two numbers, which is larger? That's what this function will be determining. And it'll return that answer to the main. It'll return the larger one to the main. Greg, you have a question?
Yeah, so in the beginning of the program, when we declare our variables, so like float, find, max, those parentheses would still be empty, right? It's not until we call them in the body of the main that we would have to fill in float num1, float num2.
Not in the body. This is still right in the header of the function.
Oh,
Still the header of the function. We are building our way to the header. If the function doesn't receive anything, then the parentheses will be empty in the header. If the function is going to receive something, then you have to have variables to receive them. That should be in the parentheses. Okay, and so now the complete general form of the function will be this. Return type first in the header as part of the header. The very first line is called the header. You'll have a return type. You'll have the name for the function. And then you'll have what we call parameters declared. Parameters are variables to receive values. And you need to declare them individually within the parentheses. Okay. And then you write the body of the program in the brackets. In this body of the program, you're processing the values received here. The values received here will be processed to find the answer. Okay, so now I'm going to write this function find max. You will understand it better if I write that function. I'm going to write the function find max on the board. All right, find max will receive two float type numbers and it'll return the larger one. It'll determine which is the larger one and it'll return that. Okay, everybody's with me with the problem? The problem is to write a function called find max that'll receive two numbers and it will return the larger one. Okay, so it's going to be float type numbers it will receive and it will return the larger one, which is going to be float. So it'll be float find max parentheses float x. I can call them xy, don't have to have longer names. Float y, you have to individually declare them. And then inside the body, all I need to do is determine which of the values in x and y are larger. X and y now have values. So when you write the body of the program, you can assume that x and y have the values that you need to process. And what processing do I need to do? I need to determine which is larger. So I need to say if I can introduce a variable max. I mean, really it's not really necessary, but we'll do it that way so that you can follow that. I can declare a variable local to this function called float max. And then I can declare, I can now start the work. If x is greater than y, when you write the body of the program, you assume your numbers are in x and y. X and y have the values, okay? So if x is greater than y, then max equal to x, right? Okay, else max equal to y. So now we have the answer in the variable max. So what you do next is return max. Whatever the max has is our answer. Take it back to the main. That's what you're saying. And close. So now this value of max will be taken back to the main. Now remember, in the main, this variable max will not be recognized. because when you declare the variable float max inside the function, it's only understood within the function. It is not understood outside of the function. So main program doesn't know max, but the returned value will go in a certain way. We'll understand that in section 5.2. The value being returned is max. So for now, we will focus on writing the functions. Let's go to the next one. I already did that. So here's the function. I already built it on the board. You just determine which is larger and return that to the main. Okay, let's go and write square. Function square. Function square will receive a number and it will return the square. We are doing elementary project right now because we want to understand the idea of functions. These are elementary tasks, but we will build our way into harder tasks. So this function needs to receive one number and will return the square of it. So to receive one number, I have one parameter. So what you write inside the parentheses here is called parameter. It will receive a value and it will return the square of that number, and therefore return type is int. And I'm declaring a local variable answer, and then answer equal to num times num, square of num, and return the answer. That's all the function will be.
So whenever there's a return or a call function, there's always going to be a new variable that has to be declared within the function.
No, you don't have to. Right now, I'm using new variable to store the answer so that you can understand it better. But I'm going to show you that you don't have to have local variable. You can go right to the answer and return it. So here's a better version. Here's a different version of this. This one has a variable answer, local variable, and stores num times num. But you don't have to do all that. You can even write it this way, directly return num times num, right there. And that is going to return square of the number, right? Greg, you have a question? Okay.
No, yeah, that just pretty much answered my last question about like assigning a new variable, right? Yeah.
Right, you don't have to have a new variable. You can do this. You can do the computation and return it right there. Okay, so function write text. All right, I don't need to explain that. I already explained it. Wait type, that's what it is. All right, here's the function that'll find average of 3 numbers. You receive 3 numbers and find the average. Okay, so to receive 3 numbers, I had to have 3 parameters individually declared like that in parentheses. That's called parameters, list of parameters. And that's where the numbers will come in. And then you only have to find the average of those and return that. So when I calculate the average, it'll be a float type. So that's why return type is float. Otherwise, I mean, average will be expected to be float type. It will have fractional values. So this function will receive 3 numbers and it will return the average of the 3 numbers. Okay. Let's see if you can write these functions. Write a function called digit that will receive an integer and return the last digit of it. The function is called digit. It will receive an integer and return the last digit. You remember how to extract last digit of an integer? Anybody?
Yeah, you modulus 10.
Modulus 10. Any integer number modulus 10 will be the last digit of the number. So use that to return the last digit. Okay, put the answer in the chat. Okay, Greg wrote an answer and it is correct. Everybody can see that. Int digit, int num, return num modulus 10. That's all it is. All right, so I want you to write the second one. The first one is very clear. If one person writes it, then everybody can see. There's no point. I'll put the answer for the first one on the board, but you should work on the second one. All right. Work on the second one. I'm writing the answer for the first one on the board. Int digit int n. You can make up any name for the parameter, and then you can say return n modulus 10. That'll be the last digit. It'll return the last digit. Okay, your function for the second one will be called surface. You'll find the surface area of a cylinder, which is given by that. Oh. Given by the formula here. But how many things do we need to receive to do the work? We need to receive the radius and height, right? R and H. So those two numbers have to come from the main. So you need parameters for radius, float, R for the radius, float, H for the height. You need to receive those. And then locally, I need to declare float const pi equal to 3.1412. And then calculate 2 times pi times R times H plus R and return that. That's it, right?
Would I have to declare pi as a constant float, or could I just leave that in the return statement as a numerical value?
Put the 3.1412 here. You can put the number directly there. Yeah, if you put the number directly there, there's nothing wrong with that, but it's better to write the word, write the constant pi. It'll be clean. Any reader can understand what that means. Okay, so you understand the idea. Okay, here is another problem. Write a function that will return a character, and it'll determine whether it's a lowercase alphabet or not. If it is lowercase alphabet, it'll return 1, otherwise it'll return 0. That's what the program, the question says. Our program will return, a function will return a 1 if the received character is a lowercase alphabet. It'll return 0 otherwise. Okay. Then all you have to do is have a char type variable to receive the character. And the return type is, return value is a 1 or 0. So the return type is int, and the name is lower alpha. So if the received character is lowercase alphabet, it'll return 1. Otherwise means if it is not lowercase alphabet, it can be anything else, not necessarily uppercase letter or some other character, it can be anything. Then you return 0. So if val is more than 97 or and less than or equal to 122, then it is lowercase alphabet. Now, do I have to use those numbers there? Not necessarily. I can actually write it this way. So let me write, I use numbers because it's convenient, but if you don't remember those numbers, you can write it this way. If val is greater than 97 here represents lowercase a, I can actually put lowercase a right there. And this inequality is valid. You can compare the character val. Val is a character. Compare that to lowercase a. And so if val is greater than a is true, and val is less than or equal to, that's greater than or equal to actually, and less than or equal to z, lowercase z with quotes. You can write that. There's nothing wrong with that. Instead of writing those letters, I wrote the numbers. Either way is correct. So if both of these conditions are true, then it is lowercase letter. So return 1, otherwise return 0. Okay. So now let's go to the next page. So you have seen return, the return, if the function is a void type, then it's not going to return anything, right? Normally void type means function doesn't return anything to the main. So in that case, you don't have to write a return statement if it is void type. In the main program is a function too, and that's why the main program has this empty parentheses. The main has a parentheses which is empty usually. That's because main is also a function, but it is the main function in the entire program. And because it's a function and it has to return something, and that's why in the early version of the languages, a return statement is necessary for a function. And so you write a dummy statement return 0 in the main to satisfy that need. That was required in the early version of all the programming languages. But in the new version, that requirement has been eliminated. So the return 0 is no longer needed in the main. Okay, so some of you have seen that return 0, so you started writing that yourself, but it's not needed. It's really a dummy statement. But the main should have the empty parentheses, and the parentheses is, and sometimes we write things in the parentheses. That's only in advanced programming you need to understand why we need something in the parentheses. But at this level of programming, you don't need that. So the parentheses in the main will remain empty. Okay, so let's do this warm-up exercise. Write a function called toUpper that receives an alphabet. And all we know is it's an alphabet. And we don't know whether it's uppercase or lowercase. So regardless of whether it's uppercase or lowercase, we need to return uppercase version of it. So if it is already uppercase, we return it as is. Otherwise, we convert it to uppercase and return. Understand the question? Okay. Okay, for those of you who don't remember how to do the conversion, let me explain. Remember the capital A to capital Z have codes 65 to 90, right? Lowercase a to lowercase z have 97 to 122. And the difference between 65 and 97 is 23.
32.
22, sorry.
32.
So 32, right, 32. The 32 is the difference between uppercase and lowercase. So lowercase a and uppercase a differ by 32. Lowercase b and uppercase b will also differ by 32. You understand that, right? The b will be 66. Uppercase b equal to 66. Lowercase b equal to 98. And the difference is 32. So all the lowercase letters and all the uppercase letters differ by 32. So that means to convert lowercase to uppercase, we subtract 32 and convert back to char. See, if I do this, let's say Val has character, and let's say Val has a lowercase character, lowercase alphabet. Then if I do Val minus 32, this will be number. Why is it number? Because when you do a subtraction with the number, even though Val is char type, before doing this subtraction, it will convert the val to int and then perform the subtraction. So the result will be int. Understand? This is character, but it'll be converted to int because for the subtraction part, both operands have to be same. So if they don't match, it'll convert both of them to larger type, which is int in this case. So the char will be converted to int, which is going to be whatever the number is for the character, and then subtract 32. So this result will be int. So to get the lowercase, uppercase alphabet, you had to convert it to char by putting a char in front of it. Now it's uppercase alphabet. Lowercase alphabet minus 32 converted to char will be uppercase alphabet.
Whoa.
Question? Okay, so that's what you need to use to do this work. The function should convert your letter to uppercase. But if it is already uppercase, you don't do anything, just return it. If it is not already uppercase, then you need to convert it and return it. All right, there's a chat. Oh, that was previous question. You can put your answer in the chat. I'll give you 2 minutes. All right, there are 2 chats. Let me check. Okay, Greg has an answer. If val 1 greater than 97 and less. Greg, you have to write val 1 again. Val 1 less than or equal to 122. Okay. And if both of them are true, then val equal to val minus 32. Okay, that's correct, since val 1 is char. Now in the parameter, in the function header, you have char in the parentheses for val 1. That parentheses should be removed. That's a declaration.
The second parentheses around char.
Yeah, in the parameter, in the header.
Right.
That should be removed because that's a declaration, it's not a conversion.
It's a declaration, not a conversion.
So val1 equal to val1 and then return val1. That's correct. Very good. Okay, so this the solution Greg wrote on the chat is correct. Everybody can see that. So any question? Anybody has any question about that? All right, let's move on. The bool data type. Remember from before, an inequality will evaluate to be true or false, and the true or false are values called logical values, and they can be stored in a bool type variable if you need to store them. And also you learned before that if you convert true to integer, it will be 1. If you convert false to integer, it will be 0. Now, by the way, in the last, in the assignment, earlier assignment, one of the questions said, write the value of expression like this, expression x greater than 0 and y less than 1, something like that. What is the value of this? And the value of the expression like this will be true or false. It will not be 1 or 0. Okay, only if you convert it to integer, it will be 1 or 0. So if I say bool x equal to this, then you're storing a true or false in x, not 1 or 0. Remember that. I gave you credit if some of you wrote 1 and 0, some of you wrote true and false. I gave you credit either way because the question wasn't clear about what is expected. Actually, it misled you by saying write 1 or 0. So that's a mistake in that question actually. So from here on, you remember, if I ask you to evaluate something like this, you only come up with true or false as answer, not 1 or 0. Only if it is converted by writing, instead of bool x, if I'm writing int x and store this, int w and store this, then w has an integer now, that'll be 1 or 0. Okay, it is not true or false if it is converted. If it is not converted, it's only true or false. So don't get that mixed up in the test. In the test, you should write true or false if it is Boolean value. Only if it has been converted to integer, then it will be 1 or 0. Okay, don't do that mix up again in the test. An expression like this should evaluate to be true or false. And you can store that true or false in a Boolean type variable by declaring it as bool, like this. X greater than 15, y equal to 3, bool is div, and then is div equal to x modulus y equal to 0. X modulus y equal to 0 will be evaluated first. And if it is equal to 0, then the value of this comparison is true. So x modulus y, 15 modulus 3 is equal to 0. So therefore, this expression is true, and therefore is div is going to have a value true. Is div will have true, not 1 or 0. All right, so suppose that we are writing a function that will determine whether the first variable is divisible by the second. So I'm receiving two numbers here, x and y, and my function is going to determine whether x is divisible by y or not. And it will return the value, return the answer as a true or false. True means it is divisible, false means it's not. So here I am answering that. I'm doing the job by doing x modulus y equal to 0. If x modulus y equal to 0 is true, then x is divisible by y. So therefore, I'm returning the value of that, true. The value of this itself is our answer, right? If this expression is true, then x is divisible by y. So I'm returning true. If this expression is false, then I'm returning false. Now, if I ask this question, some of you will write it this way. You'll say bool divisible, and then int x, int y. And then if you say if x modulus y equal to 0, that means divisible, right? X is divisible by y. Then return true. You need to return true because the function is supposed to return true or false, a bool type value. Else return, sorry, not on the same line. Else the pen works for a while and then it doesn't work. Else return false. Okay, this is not wrong. This is fine. But if x modulus y equal to 0 is true, then we are returning true. If this is false, we are returning false. So we can say return the value of this, whatever the value is, right? And that's what I wrote in this question on the book, on this slide. Whatever the value of x modulus y equal to 0 is, that is our conclusion. If it is true, then the divisibility is true. Otherwise, it's not divisible. Okay, so.
So professor, both forms are acceptable.
Yes, both are correct.
Okay.
But, you know, programmers generally, you know, try to do the least number of lines, which is what this program does, the one on the screen, right? It uses least number of statements to achieve the task. So, but the version on the board is also correct. All right, so let's do one more exercise and we'll be done. The first one, the first exercise, write a function called isEven that receives an integer, determines whether it's even or not, and returns the conclusion. So it'll return a conclusion, true or false, will be the better way, right? If it is even, you return true, otherwise false.
Professor, this is a bit off topic, but I don't think there's a question 10 for section 5.2.
I'm sorry, what's the question again?
I just said, I don't think there's a question number 10 for section 5.2.
5.2?
Yeah, for the homework.
No, the 5.2, I have to delete that because we didn't get to it.
Oh.
So The homework will not include 5.2.
Oh, okay. So just up to section 5.1?
Yeah,
Okay.
Professor, did I get the
okay.
exercise
I'm
correct?
checking now. Yes, I'm checking now. I have a solution from Greg and Greg, you cannot return a word. You're returning even, odd, you can't do that. It should be a Boolean value you should be returning. True means even, false means not even. Dylan, you're doing the same thing. You can't do that. So both are wrong. Any other answer? All right, there are some chats. Let me see. Return one. Return. Okay, if you return 1 and 0, 1 means even, 0 means odd. If that's what the function main program is expecting, then that's fine. But I already explained that you should return true or false. That's what's expected from this function, from the main. When it says determine whether it's even or not and return the conclusion, that indirectly means you return true if it is even, false otherwise. True and false are expected. If you're expected to return 1 or 0, then the problem will say that. Return 1 if it is even, false 0 otherwise. The problem has to say that. Only then you can use that. The problem doesn't say that you can return 1 or 0. So that means you have to return true or false. In that case, bool type is the return value. So the version Greg wrote is correct. It's a bool. Greg, you wrote bool and int. You cannot have two data type. Bool is even, int num. If num modulus 2 equal to 0, return true, else return false, that will be correct. So you can return 1 and 0 only if the problem says that. So this is correct. Write a function called comdiv that will return, we'll skip that. Let me explain this. Instead of you doing it, I'm going to do it. Write a function called is prime that receives an integer and determine whether or not it's a prime. Remember, is prime the prime is a number that is not divisible by anything, right? If it is divisible by anything, that is not, then it's not prime. And we wrote earlier a program that will determine whether a number is a prime or not. Now we are going to write it as a function. This function will receive a number and it will return a conclusion as to whether it's a prime or not. So when it says that return a conclusion as to whether it's a prime or not, that means return true or false. Okay. So I'm going to explain how to do that. The function is going to be called is prime. Now, by the way, there are library functions that will do this is prime and uppercase conversion from lowercase to uppercase or uppercase to lowercase. There are functions in the library. But when you're doing exercises in section 5.1 and 5.2, you cannot use any of the library functions. Remember that. You cannot use anything you haven't learned. in any exercise or any project. You can only use what you have learned at that point. So here we're writing a function called is prime. So is prime is going to return bool type answer. So it'll be bool is prime. When we wrote this as a program, it was pretty long, but when you write it as a function, it's going to be pretty short. You're going to see why. It's going to receive an integer number in the variable n, or num, we'll call it. And then if num is prime, we need to return true, otherwise return false. To do that, I need test numbers. So declare test as int test. And for test number going from 2, remember you had to test all the numbers from 2 to half of the number to see if there's a divisor. For the test going from 2 to test less than or equal to num over 2, half of the number, up to half of the number, you had to test all the integers by incrementing by 1 and see if any of these will divide the number evenly. If num modulus test is equal to 0, that means test is a divisor, right? Test is a divisor. So in the version of the program that was programmed, when we wrote it as a program, we used a flag variable called prime, and we set that to 0 up here. In the top, we set the prime to 0, and whenever, or 1, whichever, flag can be any value. And then when you find a divisor, you change that flag value to indicate that it's not prime, right? That's how we wrote that when we wrote it as a program. But when we write it as a function, we can write it slightly differently. If this is true, num modulus test is 0 for any test number, that means it's not prime, right? So instead of, I don't need to use flag variable when I'm writing it as a function. I can say, if this happens for any test number, then return false. Why? Because it's not prime, right there. So if test number, all the test numbers will be checked. If any test number divides the number num, then false will be returned, and that's the end of it. But what if none of the numbers divide? If none of the test numbers divide the num evenly, then this return statement will never be executed. That's the only time it'll come down to the next statement down here. Agree with that? That means if it comes down here without executing return statement ever, that means number is prime. So here I say return true. Are you following this? Because I'm writing it as a function, I have this convenience of return statement. So therefore, I'm saying test all these numbers. If any one of them divide the number evenly, immediately return false. That's the end of the function. It'll return. If this return is never executed, that means no number was found to be divisor. That's the only time it'll come down here. There you can say return true. If the program ever comes to this statement down here, then it'll return true because no divisor was found. So therefore the number is prime and close. So when you write it as a function, it's much easier, much shorter. You don't need the flag variable and all that. You can use the return statement to quit, to finish the job. So this is the function version. Now remember this, this prime business is important because it teaches you techniques, nice techniques. And so you should know how to write this prime as a program and as a function, depending on which the question is.
Professor.
So this is the function version. I already gave you the other version, the program version. Yeah,
Professor, I have a question about the brackets. So
yeah,
the end of the brackets would end after return true or after return false?
The function ends only here. The bracket will go here.
Okay,
Okay. You
okay.
have to return some conclusion. And so this return true is necessary as part of the function. So this is included in the function. If you put bracket here, then you're not including this in the function.
Okay,
All right.
thank you.
You can write that. So you must return one or the other conclusion, true or false. And notice the way this works. This works this way because it's a function. If any one of these test numbers divide the number evenly, then the return false will be executed and the function will end right there. When you return to the main, that's the end of the function. You're not coming back to the function. So it'll return a false if any divisor is found. Only if no divisor was ever found, then system will come to this line. This line will not be executed if any divisor is found, right? So conveniently, I can say, if the system ever comes to this line, then we'll return true. That convenience is not there in the other version. That's why we had to use the flag variable. So in the function version, you have the convenience of return statement. You have the convenience of returning to the main at any point you are. And we are taking advantage of that. All right, so that finishes the 5.1, and we will start 5.2 in the next class, which is about calling the function. So at this point, you're writing functions. You're not writing main program that will use function. You're only writing functions in 5.1. So your homework will be 4.5 and 5.1. I will delete the 5.2 part from the homework. And you have projects. Right now, I have set it to due tomorrow because another project is coming up in 5.2 for Thursday. But I'm going to change the due time tomorrow, the due time of the project tomorrow to afternoon so that you get some more time. So it's going to be due tomorrow afternoon, the project 4.5.1.
What time?
I'll change it to afternoon, like 3 o'clock, something like that. But it has to be done tomorrow because the other project is coming due Thursday. Okay. Sorry, we're back to back on tight schedule. That's what comes up. That's what happens in a winter class. Everything goes too fast. All right. Enjoy the rest of the day. I'll see you all tomorrow.
Oh, Professor, I have a question.
Sure. Those who have
For the test,
today, others can go. Yeah.
oh, for the test tomorrow is going to be start at 11, right?
Test will start at 11 and
11,
before,
and we have 2 hours. And how many questions is going to be there?
this time the number of questions will be down to about 35 because the questions are going to take longer time now. The last test took shorter time.
Because that's why, because last time it take like longer. I didn't answer like a few questions, so I think like I need more time for doing the.
Right, but about 35 questions will be there, and they will take longer time than the previous test.
So we have 2 hours for doing that.
Yes, I will give you 2 hours. So if you have you have to have the time available if you want the extra time.
Okay.
Officially, it's designed to take 1 hour and 15 minutes. So I'll go 11 to 12:30 is the official time, but I'll give you additional half an hour to make it 2 hours long if you need it, and if you have it, if you have the time.
Professor, quick question.
Yeah.
I just want to check my attendance. How is my attendance so far? I'm pretty sure it should be pretty good.
Is it Felix?
Felix.
Felix, okay. You have one lateness. Yeah, otherwise it's perfect. So you are.
For what day?
The first lateness was first day.
The first day?
First day you were late by, you were late. I don't know how long, but lateness is marked as late. But that's the only lateness, and one lateness is forgiven. So therefore you still have both rewards.
Okay, thank you.
Okay.
Ooh, can I know mine?
And with that,
Me,
Carlos?
Carlos.
Carlos, do you have bad attendance? And I wrote a message
Right.
in that assignment, and I told you to read it, and apparently you haven't read it.
Which assignment?
I don't remember now.
All right, I'll just look through all of them.
Yep, read all of them. Oh, by the way, for some reason, I'm not able to access the John Jay email. So if you have sent something to John Jay email, I haven't read it. I don't have access right now.
Oh,
Oh,
okay.
so that's why I sent you like 2-3 emails. That's why you didn't reply. I thought like
No,
Oh.
something went wrong. This is what, with the John Jay stuff, this always happens. That's why I explained in one of my messages that you should use my Gmail address, then there'll be no problems. See, Gmail works perfectly. John Jay doesn't. Okay, John Jay network always goes down and all kinds of problems occur. So use my Gmail address, then it'll be easy to communicate. All right. Okay, I have hands raised. Go ahead. Let's start with Andrews. What do you have?
Professor, so how's my attendance looking at this moment, at this point?
How's what?
How's my attendance looking at this point?
Andrews, you have. Yeah, you lost the first reward because you have 2 latenesses, but you still have second reward.
Okay. Yeah. Okay. So I'm doing fine with the camera and everything, right?
Yes.
Okay. Yeah.
Kevin?
Yeah. So yeah, just let me know if you have any concerns before, you know, kind of giving me the bad attendance. I'll see what I can do. Okay.
All right.
Thank you and have a great day.
Yeah. Hello. Professor? Hello.
Yeah.
You can hear me? Okay. No, I just wanted to remind you the project that I resubmitted. I also put like I also put the 60 as well. So I have like 4 output just to show you that like it does work. My
Okay.
my equation. Just to remind you.
Okay. You used my email address, right?
Yeah. The Professor Coogan at Gmail, right?
Yeah.
Yeah. Okay. No, I just wanted to remind you of that. Okay. All right. Thanks.
All right. Got it. Dylan?
Oh, Professor, on the test 2, the chapter it stops at is 4.5.
Yes.
Okay, thank you.
Mhm.
That's all I wanted to know.
Mhm.
Oh, so can you check my attendance, please? Ibrahim.
Okay. Ibrahima. Yeah, you also have 1 lateness and that will be forgiven. So you have both rewards.
When was the latest? Was it today?
No, not today. It was Thursday, January 6th.
Okay. How long? When was the latest?
I don't know if it is longer than 1 minute, it'll be recorded as late. That's all.
Okay. I also want to say, right? Yesterday I sent you an email. Did you see it?
No.
Can you check your email? Because
Send it again to Gmail address.
yes, I sent it on the Gmail address. Because I submitted the project and then after that I find like a mistake I did. So I tried to ask you like to reset it so I can send it again. But I sent it before it would do last night.
Before it was due, okay, then it'll be accepted. If it was sent before the due time, yeah,
Okay.
I'll upload it for you.
Okay, thank you.
Mhm.
Have a good one.
You too. Okay. All right. Everybody have a nice day. I'll see you tomorrow.